Hello and welcome to Mind Peace. It's truly lovely to have you here. Whether you've tucked yourself into bed, curled beneath soft blankets, or you're lying back with the lights dim and your thoughts drifting like leaves on a quiet stream, this space is just for you. Tonight, we begin a gentle journey through space and time, a story that hums beneath the skin of stars and the rhythm of your breath. It's called Universe in Motion, a calm exploration of why everything, absolutely everything, is always moving. Now, just a soft word of caution. I've woven this episode to be as soothing as a breeze through tall grass, but it might stir a little wonder too. If your mind stays just a little too awake, I hope at least it floats somewhere beautiful. And if you enjoy this quiet moment, we're sharing. I'd be so grateful if you tap the like button and subscribe for more gentle science like this. It helps more sleepy minds discover us, and together we can light up a soft constellation of calm, one listener at a time. And now take a breath. Let it fall. Let's begin. Your body is still, but you are not. Beneath your stillness, blood flows in looping rivers. Air stirs softly in and out of your lungs. Even if you tried to stop everything, if you lay perfectly still, even your atoms would keep on dancing. You're made of motion, and you are floating too, gently, unknowingly, on a planet spinning at 1,000 tan-on-mile. Earth carries you through space at breathtaking speeds, orbiting the sun like a silent carousel. And the sun itself, it is not anchored. It too drifts, pulled by the gravity of our galaxy, the Milky Way. A spiraling swirl of stars that races forward through the expanding universe. Stillness is only a trick of the moment, a pause in one story, while others continue. Imagine now with your mind's eye the Earth slowly rotating day into night, night into day. A rhythm so gentle you rarely feel it, but it's there. A vast, round breath beneath your feet. Imagine the moon circling us, pulling at the oceans with soft, invisible hands. Tides rise and fall like a sleeping giant's breath. And somewhere beyond, the planets spin in their own quiet ballet, each on their own track, never crashing, always curving. Motion is everywhere, and yet they're in this quiet room. It can feel like the world has stopped just for you. That paradox of silence in motion, of movement in rest, is one of the universe's most beautiful tricks. Let your thoughts drift further, now beyond the Earth. Picture the stars above you not as fixed pinpoints in a sky dome, but as travelers. Each star is moving, some quickly, some barely, through the fabric of space. You might think the night sky never changes, that the stars remain where they've always been. But if you watched long enough, not for minutes or years, but for thousands of lifetimes, you'd see it all shift. Constellations would melt and reform. Orion would stretch and dissolve. The Big Dipper would empty out one star at a time. What looks fixed is just too slow for us to notice. Even the galaxy is spinning, its arms swirling like the petals of a cosmic flower. We are tucked deep in one of those arms, the Orion arm, like a tiny passenger on a great galactic merry-go-round. It takes us 230 million years to complete just one loop around the galaxy's heart. Everything is moving, yet everything feels still. This is the dance of perspective. A tree seems still, but it grows. A rock feels solid, but its atoms tremble. A mountain appears unmoving, yet it shifts by inches every year. And far beneath it, molten rock churns and swells, keeping the land above alive. Even time itself is a form of motion, a river you cannot see, but always feel. It moves forward, never back, and it carries you with it. The future becomes now. The now becomes memory. Time rolls on. What drives all this motion? Forces, invisible but mighty. Gravity, that quiet tug that binds planets to stars and keeps your feet on the floor. Electromagnetism, which lets atoms stick and hearts beat. nuclear forces tucked into the sun's core, driving the fusion that warms your face every morning. And somewhere underneath it all, at the foundation of everything, quantum motion. Particles that blur and flicker, never truly at rest. Even in empty space, particles pop into existence and vanish again. A restless fabric beneath all form. So even in the darkest, still moment, something stirs. And that includes you. Every breath you take is part of this motion. Inhale. Air enters. Molecules shift. Your chest rises. Exhale. And the air you release joins the vast circulating winds of the earth. Right now, you're not just lying in a room. You're part of a chain of motion that connects you to volcanoes, to rivers, to stars being born. You're not separate from the universe's rhythm. You're a note in its endless song. Perhaps this is why music feels so human. It echoes a truth we carry inside. Life itself is made of cycles, of waves, of beats, heartbeats, brain waves, breath, light. Yes, even light is in motion, and it never stops. We'll get to know light more closely soon, but for now, just imagine it. A glowing traveler crossing unimaginable distances to touch your skin, or fall softly on the leaf of a tree. It always moves at the same speed, a perfect, unchanging rhythm. One that has shaped everything from time to color, to the boundaries of the universe itself. And now, as your body softens and your thoughts begin to blur, perhaps you can feel that rhythm just a little more clearly, a kind of cosmic, fully written in the quiet turning of planets, the pulsing of atoms, and the deep, slow exhale of time itself. So rest now in this truth. There is no such thing as stillness. Even now, even here, the universe hums within you. And as we drift into the next chapter, we're leaning closer to this invisible hum, to the hidden threads that hold motion and space together. Because underneath your feet and around every star, something far strange awaits. Something that bends, stretches, and weaves through everything you know. You lie in your bed surrounded by blankets, supported by a mattress, grounded by the floor beneath. It all feels solid, steady, unmoving. But beneath all that comfort is something deeper. Not just stone or soil or spinning earth, but something softer, stranger, and more fundamental. You're resting on the very fabric of the universe. It doesn't feel like fabric. You can't see it or touch it, but every step you've ever taken has pressed gently into it. Every breath you draw is measured by it. This fabric, the quiet framework, beneath everything, is what physicists call spacetime. It stretches beneath you like a net holding up the stars, curving invisibly beneath the moon, wrapping around you even now as you listen and begin to drift. Spacetime is not a thing you can pick up or point to, is not made of atoms or particles. It is more like the stage on which everything unfolds, the unseen theatre where matter performs and time keeps the beat. And yet this stage is not flat. It bends. Close your eyes and imagine placing a heavy ball on a soft sheet. The sheet dips beneath the weight, curving inward. That's how mass affects spacetime. Everything with weight from your body to the earth, from the sun to galaxies, causes this invisible fabric to curve around it. This gentle bending is what you feel as gravity, not a force pulling downward, not a mysterious tether to the ground, but a quiet slope in spacetime. You roll into it without even knowing. You don't fall to earth because earth pulls you. You fall because the earth curves the fabric beneath you, and you're simply following the line of least resistance. Like a marble rolling down a hill it didn't know was there. Even light, which has no mass at all, bends when it passes near something massive. Not because it slows, but because it follows the curves. It travels straight, but spacetime itself isn't straight. It dips and warps and twists around stars and planets and black holes. So you see, space is not empty, it is shaped, and you floating so peacefully through your night are riding that shape. It's a strange thought that space can be bent without breaking, twisted without tearing. But this is the language of Einstein's great insight. His theory of general relativity gave us this new way of seeing the cosmos, not a void with things in it, but a fabric shaped by presence. This fabric is vast, but it is also intimate. It flows beneath your pillow, beneath the clouds, beneath the sun. It connects the atoms in your hand to the dark matter that holds galaxies together. Time is woven into it too, not separate, not ticking away on the side, but fully entangled. Space and time, one single entity. This is why we call it spacetime. And just as space bends near mass, time stretches near a massive object like a planet or star. Time moves more slowly, just a little, but enough to matter, enough to be measured. Time itself, that river we float in, slows down near gravity's curves. This is why astronauts, after circling the Earth at high speeds, return just a tiny bit younger than the people they left behind. They've experienced time a little differently because they've skimmed the edges of a bent space-time. Here in your quiet room, you don't feel any of this bending or slowing, but it's happening all around you. You live your whole life in a woven, curved, dynamic fabric, invisible but always present. And this fabric moves. It doesn't just sit there. The universe is expanding, not into something, but from within itself. The fabric of space-time stretches, like dough rising in the oven. Galaxies don't fly away from each other through space. They are pulled apart because space itself is growing between them. Imagine raisins in a rising loaf of bread. The raisins aren't moving much, but the dough between them expands. So it is with stars and galaxies. And as space expands, time flows forward, never backward. Entropy nudges it in one direction, like wind pushing a drifting boat. This gentle, steady unfolding is what allows the universe to exist at all. A stretching fabric, a ticking time, and the quiet hum of motion we began to explore in the last chapter. But here's the beautiful part. Despite its vastness, space-time is not cold or distant. It is the very thing that allows you to lie in your bed, to breathe, to dream. It connects you to the furthest galaxies, to the slow spin-off Jupiter's storms, to the cradle of starlight in ancient clouds of dust. Right now, space-time bends gently beneath your body. The Earth shapes it. The moon stirs it. The sun presses into it like a weight into velvet. And all of it holds you. Not tightly, not harshly, but with quiet, patient grace. It is a comfort to know that even in silence, even in stillness, there is structure, a pattern beneath the random, a softness beneath the hard. And perhaps, as you drift closer to sleep, you can imagine yourself not just lying on a bed, but floating gently on the curves of space and time itself, held in a hammock of gravity, rocked by the slow breath of the cosmos. And just beneath that curve, something else stirs. A rhythm even faster than the spin of stars. A flickering presence that never stops moving. Because next, we'll travel into light. Not just what we see, but what it is. You traveler without rest, a constant through space and time. What is light really? And how does it always know exactly how fast to go? Light feels so simple. A flick of a switch and it appears. It fills a room, spills across a pillow, glints off glass, then quietly fades when you close your eyes. But light is never simple. Even now, as you lie still in the hush of night, light is moving all around you, passing through windows, whispering in starlight, warming your skin, humming across empty air. Light doesn't need anything to carry it. It doesn't need wires or window wheels. It moves freely, even through the vacuum of space, as if space itself was made for it. And in a way, it is. You see, light isn't just what you see. It is seeing. It's how your eyes connect to the world, how the past becomes visible. Because light takes time to travel. Every bit of it brings a memory. When you look at the stars, you aren't seeing them now. You're seeing where they were sometimes hundreds or thousands of years ago. Light is a messenger from the past. But what is it really? It helps to think of light as a kind of rhythm, not solid, not static, but pulsing. A wave that moves in tiny, invisible ripples. These ripples are made not of sound, like the waves in air or water, like the waves on the sea, but of electric and magnetic fields dancing together. This is what light truly is, an electromagnetic wave. Two fields that pull and push, curling through space in perfect step, like two dancers who never touch but move in tune. One twisting one way, the other responding again and again across the void. You can't see most of this dance, only a tiny slice. The visible spectrum reaches your eyes. The rest, it stretches far and wide. There's infrared, the warmth you feel from a campfire. Ultraviolet, which paints the wings of butterflies and can burn your skin in summer. There are radio waves, microwaves, X-rays, and gamma rays. All are forms of light, just vibrating at different speeds. So light is vast, much more than the glow of a lamp or the shimmer of stars. It's a wide spectrum of invisible songs flowing around you all the time. And it is fast, very fast. The speed of a light is the fastest anything can go, around 300,000 km/s. Fast enough to circle the Earth more than 7 times in a single second. But more than that, it's constant. No matter how fast you move or where you are, light always travels at the same speed. Whether you're standing still or soaring through space, light moves past you just as quickly. It does not slow down or speed up for anyone. This is one of the most mysterious things in all of physics and one of the most important. It means that time and space must shift around it. Because light refuses to change speed, everything else must adjust instead. Time may slow, distances may shrink, but light always keeps its pace. It is the universe's metronome. Light doesn't experience time the way you do. For you, a journey takes seconds or hours, but for a particle of light, called a photon, time doesn't pass at all. From the photon's point of view, its entire journey happens in an instant. It is born and it arrives all at once. That's hard to imagine, but it's true. For light, the idea of before and after simply dissolves. Light is stemless and nearly weightless. It has no mass. That's part of what allows it to move so freely. It doesn't need to push through like a car in the wind. It simply moves elegantly without resistance. And yet, despite its weightlessness, light carries energy. A single photon can knock electrons loose from atoms. Entire solar panels rely on this gentle push, the soft nudge of light converting directly into power. It warms your skin. It gives life to plants. It powers weather systems. It even holds the clues to the origins of the universe, locked inside the faint glow of the cosmic microwave background. Ancient light still drifting through the cosmos, billions of years after the Big Bang. Light is the great storyteller. Everything you see because light bounced off it. The moon glows because it borrows sunlight. A leaf is green because it reflects certain wavelengths and absorbs others. Even the shadows in your room are shaped by light's path, where it can reach and where it cannot. But light isn't just a wave, it is also a particle. This is one of light's strangest qualities. It acts like a wave when it moves, spreading and rippling and bending. But when it hits something, a surface, an atom, your eye, it behaves like a particle, a tiny packet of energy arriving with a tap. Wave and particle, one and the same. Note either or, but both. Light refuses to be just one thing. It's a paradox at the heart of quantum physics. Something we'll explore more in time. But for now, let this image settle in your mind. Light as a traveler. It leaves the sun and journeys 8 minutes across space to touch your cheek. It bounces off Saturn's rings and into telescopes. It crosses galaxies to reach our eyes. Some light, born in the hearts of stars long gone, is only now arriving. Each beam carries not just brightness, but a story of time, of place, of movement. And through all of it, it moves with perfect speed. No faster, no slower, always the same. That speed defines so much more than just motion. It sets a cosmic limit, a boundary for what's possible. It shapes the structure of time, the shape of space, and the limits of cause and effect. Why can't anything go faster than light? Why does it matter that this speed is fixed? Those are the questions waiting on the other side of tonight's horizon. Because as we drift into the next chapter, we'll sit beside this universal constant, this sacred speed, and ask why it never changes. Why does light always know exactly how fast to go? And what would happen if anything tried to go faster? You've met light now, not just as brightness, but as motion, rhythm, and story. Tonight, we'll linger with it a little longer. We don't rush. We stay with the steady beat, because light moves at a pace that never changes, not ever. And that one simple truth shapes everything you know. It's called the speed of light in a vacuum. And it's not just fast, it's the fastest anything can go. Roughly 299,792 music kms. A number so large it's hard to imagine. But more than just a number, this speed is a boundary, a cosmic law, a kind of heartbeat built into the fabric of reality. And here is the astonishing part. No matter how fast you're moving, thus no matter whether you run, ride, or rocket through space, light always moves at the same speed relative to you. It doesn't matter if you're moving toward it or away from it. The speed you measure will always be the same. No variation, no catching up, no slowing down, just that steady, unwavering pace. This might feel strange. If you were chasing a car, you'd see it getting closer more slowly. If you ran alongside a sound wave, it would sound lower, stretched out, but not with light. You could be flying half the speed of light toward a beam, and it would still rush past. Ain't you just as fast? You could try to outrun it, and fail every time, because light isn't adjusting to you. Everything else adjusts around it. That's the strange beauty of it. And that's what Einstein understood more than a century ago. He saw that if the speed of light was always constant, then the only thing that could change was space and time themselves. And so they do. Time stretches, space contracts, mass increases, all to keep light speed the same. It's as if the universe protects that number, guarding it, bending itself to ensure nothing ever overtakes it. This is why we call the speed of light a universal constant. It never tires. It never swerves. It simply is. Even in the deepest vacuum of space, where there's nothing to slow it, light still keeps to that same pace. It doesn't speed up, even though it could, because it's not moving through space the way a car moves down a road. It's riding the very shape of space-time itself. It's like a ripple on the surface of a pond, except the pond is invisible, and the ripple never fades. And here's something softer, something stranger. The speed of light is more than just a measurement of motion. It's baked into the structure of how the universe works, into equations, into the balance between matter and energy, into the very tick of time. Without it, time would not behave as it does. Without it, cause and effect might not hold. Without it, there could be no limit to motion and no protection against chaos. You see, this limit, this cap on speed keeps reality stable. Your ship responds. The universe around you begins to blur, not from motion, but from distortion. Time inside your vessel begins to slow, just slightly at first. But with each increase in speed, the seconds stretch further. Your body feels no change. Your heartbeat remains calm. But the outside world races forward, growing older while you drift in your own suspended moment. You try to go faster. But here is where the universe pushes back. To reach 90% the speed of light, you need a huge amount of energy. To reach 99%, the energy required becomes staggering. And to reach exactly the speed of light, it would take infinite energy. That word infinite is where the laws of physics draw the line. It's not a mechanical issue, not a matter of parts or power. It's a truth built into the fabric of reality. No object with mass, no ship, no particle, no body can ever be pushed to that perfect speed. Why? Because mass itself begins to change. As you approach light speed, your mass increases. not in the way we feel weight on Earth, but in the way energy and matter are intertwined. More speed means more energy, and more energy, according to Einstein's equation, E pi mc2, means more effective mass. Your ship grows heavier, not by adding parts, but by becoming more resistant to motion. Each burst of power moves you forward less and less until eventually no amount of energy can push you further. Light remains ahead, always just out of reach. This is the ultimate speed limit, not like a sign on a road, but like a horizon, something you can approach but never touch. And so we understand now why light is the fastest thing there is. It isn't just a champion in a race, it isn't just quick. It's the only thing that moves at light speed, because it has no mass at all. It doesn't need energy to reach that speed. It was born there. It lives there. It moves through the universe as naturally as a thought moves through a dream. You, however, are made of mass. Even the smallest particle with mass must obey the same rule. It can move fast, unimaginably fast, but it can never become light. There is always a distance, a breath, a gap that cannot be crossed. And so you float in this quiet chase, closer and closer to a boundary you can feel but not reach, a wall that never meets you but shapes everything you know. Because this limit has consequences. It means there is a maximum speed for information. Nothing, not a message, not a signal, not a whisper, can travel faster than light. No call from one star to another can arrive instantly. No rescue from the edge of a black hole. No instant memory from across time. This limit is the reason the universe has order. It keeps cause before effect. It gives time direction. It stops paradoxes from unraveling the story of existence. Imagine again your journey through space. You're traveling at 99.9% the speed of light. From your perspective, only a short time passes. But back on Earth, decades slip by. People age, cities change. Maybe the stars themselves begin to shift. To you, it feels like an instant. But for the universe, you have skipped ahead. And yet you are not light. You are still within time, still within the rules. Because even as you bend time, you do not break it. This is where the wonder lies. In the fact that the limit exists, not as a punishment, but as a quiet protection, a reminder that the universe has edges, soft and silent, where it asks us not to cross. But there are other ways to explore, other boundaries to approach. We've been thinking about speed, about motion through space, but there's another form of chase happening all around you. One that doesn't need rockets or engines. One that shapes the way ice melts, stars fade, and dreams dissolve. It's the chase of disorder. The slow drift from structure into scatter, from warmth into cool, from complex into simple. This isn't about speed in kilometers s. It's about a deeper current, something that moves not through space, but through change. And this is where we meet entropy, a word that sounds cold, maybe distant, but carries the soft hum of inevitability. Entropy is not a villain, it's not destruction, it's the gentle settling of the universe into balance. So, as your ship slows now, as the stars drift back into place, as your breath returns to its slow, sleeping rhythm, prepare to step into that quieter realm. Because even if you never move again, entropy is already in motion, and it's taking everything with it. You are moving through stillness now, not in a ship this time, but with your thoughts, weightless, drifting, unhurried, and just behind your quiet breath, that question still lingers. Why really can nothing go faster than light? It's not just a number on a chalkboard, not just a fact to memorize. It's something deep embedded in the shape of the universe itself. Tonight, we look gently into that truth. Begin here. Motion takes energy. To move a body, to push it, lift it, carry it forward, you must add energy. Even walking across the room takes a little. A car needs more, a rocket even more still. But the faster you go, the harder it becomes, because you're not just pushing through air or gravity. You're pushing through the rules of spacetime. And as you begin to approach light speed, something changes. The energy you add doesn't just make you go faster. It starts to make you heavier. Not in the way we feel weight on Earth, but in terms of inertia, that quiet resistance to motion. The more energy you feed in, the more mass you gain. A strange kind of mass, a reluctant one. At first, it's manageable, like cycling up a gentle slope, but soon the hill steepens. The closer you get to light speed, the steeper it becomes, and near the end, it becomes a vertical wall. The energy needed doesn't just increase, it skyrockets. To move an object with mass at the speed of light would take infinite energy, and there is no infinity in nature. This is why no amount of fuel, no perfect engine, no clever design can break the limit. Not for a ship, not for a particle, not even for the tiniest speck of matter. The universe has sealed that door. But instead of feeling frustrated, perhaps, you can feel something else, a quiet, or that there is such a limit, that something in this vast expanding cosmos keeps order so gently, so precisely. It's like trying to touch the edge of a dream. The closer you reach, the more it fades. This isn't just a mechanical boundary. It's a law of how energy and matter speak to each other. Remember Einstein's famous equation, E=mc². It tells us that energy and mass are two sides of the same coin. The c in that equation, the speed of light, is more than a number. It's a bridge between what is and what could be. It means mass is energy, and energy given the right form can become mass. But to accelerate mass to light speed, that's asking it to become something it isn't, to transform completely, endlessly, without end. And the universe won't allow that. It guards the integrity of matter, of motion, of time. And there's something deeply comforting in that. Because if things could move faster than light, reality itself would unravel. Messages could travel backward in time. Events could occur before their causes. Paradoxes would multiply like ripples with no source. The flow of time would become a whirlpool, no longer a stream, but a storm. So the speed limit exists not to confine us, but to protect the story of the cosmos. And still there are beings, particles that do travel at the speed of light. They are the massless ones, photons of light, perhaps gluons in the nucleus, maybe even the elusive graviton if it exists. These particles don't obey the same rules because they were never part of the chase. They start at light speed. And because they have no mass, they never slow down. They don't experience time. They don't have rest. They exist as movement. They are the exceptions that prove the rule. And here's another secret. There may even be particles that go faster than light called tachons. Hypothetical, mysterious, never seen. They belong more to the edge of mathematics than to the real touchable world. If they do exist, they would break the usual flow of time. They would never slow down below light speed, and they might not obey causality, that gentle order of cause and effect. But for now, they remain unproven, just a soft possibility, folded into the math, waiting at the edge of maybe. So you can rest tonight, knowing that nothing known, nothing with mass, nothing made of matter can break the speed of light. Not because we aren't clever, not because we haven't tried, but because it is a truth more fundamental than gravity, more enduring than stone. And in this limit there is peace, a quiet cosmic ceiling that shapes all we do, how we explore, how we look into the sky and see the past coming toward us in beams of light. And though we can't break the limit, we can approach it. We can send particles in great accelerators to within a breath of it. We can watch muons, particles born in the upper atmosphere, live longer than they should because time bends near light, speed. We can travel in thought, if not in form, and in doing so, we glimpse the edge of what's possible. We learn what holds the universe steady, what keeps time in step, what keeps matter from falling into chaos. So tonight, as you float gently in the rhythms of rest, remember that limit, not as a wall, but as a woven thread, a thread that ties energy to motion, motion to time, time to history. And just beyond that thread, we begin to feel something else. Not speed, not motion, but change. Not the chase of rockets, but the slow unfolding of systems. The way ice melts, the way stars burn, the way memory fades. This change too has a rule, a rhythm. It is the law of entropy, and it is already inside you, moving quietly even now. Close your eyes for a moment and imagine a glass of ice water. Cold, still perfect. Ice cubes resting clear and crisp. But you know what will happen next. Slowly they begin to melt. The cubes soften, blur at the edges, dissolve into the water they once stood against. The glass warms. The temperature evens out. This is entropy. The quiet pull toward balance. The soft unraveling of order into something more scattered, more mixed, more diffuse. You can think of entropy as a kind of whisper, not loud or sudden, but persistent. It's not chaos. It's not destruction. It's the gentle shift from the arranged to the natural, from structure to stillness. And it's happening everywhere all the time, in the cooling of a star, in the fading of a scent, in the way your coffee loses heat as it sits too long, even in your own body, the slow drift of cells, in the software of memory. Entropy hums beneath the surface. It is not a villain. It is the universe's way of unfolding. In science, entropy is often called a measure of disorder. But that word disorder can feel sharp, even a little harsh. Instead, think of entropy as freedom, as possibility, as the number of ways a system can be arranged without losing its overall identity. A neat stack of playing cards has low entropy, very few arrangements, very little freedom. But shuffle them, and the possibilities explode. The deck becomes more free, more likely to stay jumbled than to fall back into order. This tendency toward disorder isn't just common, it's guaranteed. The second law of thermodynamics tells us that in any closed system, entropy always increases. Left alone, things scatter, heat spreads, particles disperse, and energy becomes harder and harder to use. That's why your tea cools, not heats. Why your room gathers dust, not order. Why a house falls apart over time, not together. The universe moves from the improbable toward the probable, from structured beginnings to relaxed endings. But here's the beautiful thing. This increase in entropy is what makes change possible. Without entropy, there would be no direction to time, no arrow pointing forward. Everything would remain balanced, static, stuck. But with entropy, time flows, events unfold, stars are born, and then they die. New things emerge, old things fade. Entropy is not just about decay, it's about transformation. Imagine again that glass of ice water. As it melts, it becomes something new, a mixture, not a loss. The order changes shape. The ice becomes water. The energy spreads. And that spreading is key. Entropy is tied to energy, specifically to how energy moves and how much of it is available to do useful work. As entropy rises, energy becomes more dispersed, less concentrated, still there, but harder to gather, harder to direct. This is why machines wear down, why engines need fuel, why we grow tired. Energy isn't vanishing. It's just being shared more widely, becoming harder to harness. This idea is everywhere in nature, in physics, in your life. Entropy explains why a dropped plate shatters but never unshatters, why smoke spreads but never contracts back into the fire, why you remember the past but not the future. It's not just about randomness, it's about probability. There are more ways for things to be disordered than ordered, and so over time they become more likely to land in one of those disordered states. It's like walking into a forest with only one narrow path. The moment you step off, you're surrounded by infinite directions, and the longer you wander, the less likely it is you'll return to the path by accident. This is the universe's natural movement from unlikely to likely, from symmetry to variation, from tight control to relaxed form, and in this quiet drift, time is born. Because entropy only goes one way, it gives time a direction. the arrow of time, as physicists call it. Without entropy increasing, there would be no distinction between past and future, no flow, no story. It's entropy that makes the future open and the past closed. And so, your life moves forward one breath at a time. Not because time wants to pass, but because change keeps happening, because systems keep relaxing, because the energy you carry keeps spreading just a little more with every moment. And yet, here's the quiet surprise. In small corners of the universe, entropy can decrease not in total, but locally for a while, with the help of energy. This is how life happens. Your body is a small miracle of temporary order. You eat food stored, energy, and use it to build and repair, to organize cells, to remember names, to dream. In doing so, you increase entropy elsewhere in the food you digest, in the heat your body radiates. But locally, for a time, you create order. So do stars. So do galaxies. So do ecosystems, cities, and poems. Entropy allows complexity to exist. It makes room for structure, Taurus, even if only briefly. And then, like a wave washing up on shore, it returns, softening the edges, quieting the shapes. And in that pattern, rise, spread, dissolve. You find a kind of rhythm, the rhythm of the universe breathing, creation, change, release. You're not separate from entropy. You're part of it, held by it, carried forward in its long, quiet tide. And just like heat, just like light, just like motion, entropy has no end in sight. It keeps flowing, it keeps humming. The stars will burn out, the galaxies will thin. Even black holes may evaporate one day, and far into the future, deeper than time can yet reach, the universe may settle into its final form, cold, quiet, and full of possibilities that no longer stir. That distant moment is sometimes called the heat death of the universe. Not a sudden end, but a soft sigh, a final exhale, where everything has reached balance. No gradients, no movement, just evenness. But we're not there yet, not even close. Right now, energy still flows, change still happens. Entropy still climbs. And in the next chapter, we'll follow that climb a little further, as it becomes not just a whisper in your tea or your breath, but the arrow that carries you forward. We'll ask why time moves only in one direction and whether that direction is as fixed as it seems. Time feels simple when you watch a clock. The second hand ticks forward. The minutes gather, the hours pass. Morning becomes afternoon, becomes night. It feels like time is marching, step after step in one direction. But tonight, let's look more closely. Not the clock itself, but at the arrow it follows. This arrow, the direction of time, is not drawn by ticking hands or calendar pages. It's drawn by entropy. That quiet drift we met before, that whisper of change, it's entropy that gives time its shape. Imagine this. You drop a glass. It falls, shatters into 1,000 shards. You watch it break. You hear it. You feel the moment. And yet, you've never seen the reverse. Never seen shards leap up, find each other, reform into a perfect cup. Why? Because there are more ways to be, broken than whole. It's not that the laws of physics forbid the reverse. Technically, the equations of motion work in both directions. They don't care if you play them forward or backward. But entropy does. It tells us that systems tend to move from order to disorder. Not because they're forced to, but because that's simply what's most likely, what's most probable. It's not impossible for the glass to reassemble, but it's so unlikely that it might as well be. So the arrow of time, the direction from past to future, is carved by the way entropy increases. Not by clocks, not by memory, but by this natural movement toward greater possibility. And it's everywhere. Fire burns, ash remains, smoke spreads, but never rewinds. You grow older, your skin softens. You learn, forget, and remember in ways that never exactly reverse. The past solidifies and the future stays unknown. Entropy gives time its story. You don't remember the future, not because you're forgetful, but because it hasn't been written. The low entropy past is where order lived, where patterns were clearer. The high entropy future is where randomness expands, where the possible outnumbers the known, and so we move forward. Entropy is why memories form after experiences, why causes come before effects, why the sun rises again tomorrow, not yesterday. It is what makes time feel real, not just as a measurement, but as a movement. And though it may seem strange, the early universe had incredibly low entropy. In the beginning, in those first bright moments after the Big Bang, the cosmos was hot, dense, smooth, but not yet mixed. The energy was concentrated, the matter was simple, the potential was enormous. Since then, entropy has only increased. Galaxies formed, stars ignited, planets took shape, life emerged, changed, and changed again, each moment adding a little more complexity, a little more randomness, a little more irreversibility. Even now, every breath you take leaves a mark, a tiny footprint in the air, a trail of molecules rearranged. There is no perfect rewind. Time's arrow is drawn gently, not with force, but with flow. But is it absolute? Could the arrow of time ever reverse? Some physicists have asked this question, not because they expect to wake up yesterday, but because they want to understand why the universe started with so little entropy to begin with. If the laws of physics don't care which way time runs, why did time start going forward? That's still a mystery. It may be that the universe's low entropy beginning was a rare and beautiful starting point, a deep breath before everything began to spread. Or perhaps time, as we experience it, is only one part of a larger whole, like one page in a long folded book. But here, now for you, time flows in one direction, always forward, and entropy, quiet and patient, carries you with it. You feel it not just in decay, but in life, in how you change, in how the world moves around you, in how moments refuse to return the way they came. It gives life shape. It gives stories their arc. It gives you the comfort of knowing that no matter how strange the universe may be, the past is behind you, and the future still waiting. And this arrow, this subtle guide, helps the universe evolve. Stars shine because energy moves from hot to cold, from dense to spread. Because if something could travel faster than light, it could outrun time. Events could happen before their causes. You could arrive before you left. Effects might ripple back to rewrite their own beginnings. This would undo everything. So, the speed of light is not just about speed. It's about order, about protecting the flow of time, the balance of energy, the quiet rules that let galaxies turn and atoms bond, and minds like yours ask questions at the edge of sleep. It's comforting in a way to know that in a universe so vast and unpredictable, there is one rhythm that never falters. And yet, light speed isn't infinite. That's important too, because it's finite. Light takes time to move from place to place. From the sun to your face, 8 minutes. From a nearby star, years from distant galaxies, billions of years. That slowness, relative as it is, means that when you look into the sky, you look into the past. It means there's no way to send a message faster than light. No instant answers, no skipping ahead. Everything we learn about the universe arrives with delay. The cosmos reveals itself at its own pace, but within that delay is something beautiful. It's why we can look back in time, why we can see how galaxies formed, how stars were born, how the universe began. Because light has traveled patiently across unimaginable distance just to reach your eyes or your telescope or your imagination as you lie here now. And because that speed is constant, we can measure it, predict it, use it like a cosmic ruler to chart distances too vast for steps or wheels. It becomes a tool of wonder, not just a limit, but a guide. Even the word light year, so familiar now, is born of this idea, not a unit of time, but of distance. How far light can travel in 1 Earth year? Nearly 10 trillion kilometers. Every time you hear that phrase, you're hearing the echo of light's steady march. And it's this constancy that makes science possible, that lets astronomers map these stars, physicists build theories, and engineers design satellites that can beam information across oceans of space. Even here on Earth, our GPS systems, our data networks, our everyday communications depend on light's consistency. Photons pulsing through fiber optic cables, clocks syncing by the tiniest shivers of time. You're held in place in part by this unwavering speed. And yet, for all its strength, light can be slowed. Not in a vacuum, but when it passes through glass, or water, or air, it takes a little longer. The wave is delayed, bent, nudged, paused just enough to change direction or color or speed. Even diamonds slow it by more than half. And still, when light emerges again into emptiness, it returns to its original pace. Like a runner slipping back into stride, it remembers. There is something tender in that, something steadying. No matter what it passes through, no matter what bends or distorts it, light always finds its speed again. It always remembers who it is. Perhaps you can take comfort in that in your own life. You pass through different layers of emotion, of change, of uncertainty. But beneath it all, there is something steady inside you too, a rhythm that remembers who you are. So rest now, wrapped in that thought, wrapped in the constancy of light, in the truth that some things never waver. And as you drift a little deeper, we'll step closer to something even stranger. Because if a light always moves at the same speed, what happens when you try to match it? What happens to time? When you chase the constant, time feels steady. You watch seconds pass one after another as in perfect rhythm. A clock ticks, a heart beats, the sun rises, and later it sets. From morning to night, time seems smooth and faithful, a quiet companion moving beside you. But tonight, we leave that familiar rhythm, because time does not tick the same for everyone. You're lying still now, calm and slow. But imagine someone rushing past you, running, cycling, flying. As they move faster, something begins to change. Not just their speed, but their time. Time begins to stretch. The faster someone moves through space, the slower they move through time. This idea may feel impossible, like a trick of language, but it is one of the most well-tested truths in all of physics. Time is not absolute. It bends, it flexes, it changes depending on how you move. This bending is called time dilation. It's not just a theory, it happens. GPS satellites orbiting high above Earth experience time slightly faster than clocks down here. A difference so real, engineers must correct for it daily, or your maps would drift wildly off course. Even your own body experiences it. Right now, as you lie in gravity's gentle pull, time is passing just a touch slower for you than it is for someone in a plane above. It's such a tiny effect, billions of a second, that you'll never feel it. But it's there, and it's a clue. Because as speed increases, so does the stretch. Picture a spaceship, sleek and silent, accelerating faster and faster. As it nears the speed of light, strange things begin to happen. Not to the ship, perhaps, not to the astronaut inside who feels normal, steady, and calm, but to us, watching from afar. From our perspective, their clocks tick slower, their gestures stretch out. If they wave, the motion is drawn thin, like syrup pouring slowly. If they move fast enough, say 90% the speed of light, a single hour for them could feel like 2 for someone watching. At 99%, it could be 7. At 99.9999%, whole years might pass. For us, while minutes tick for them. To them, nothing feels wrong. But to the rest of the universe, time has softened around them. It's not a trick of light. It's not a glitch. It's reality. The faster you move, the more time lets go. Imagine that. Running fast enough that time itself begins to give way, as though you're gliding, not just through space, but through the folds of time's fabric. But speed isn't the only way time bends. Gravity does it too. Remember the curves of spacetime we explored earlier? The deeper the curve, the stronger the gravity, the slower time moves. Not in metaphor, in truth. This is why time ticks more slowly, near a black hole. Its pull is so strong, curves sharply inward. clocks near the event horizon, that dark edge where even light cannot escape, tick slower and slower until from the outside they seem to nearly stop. To someone falling in, time flows as always, but to a distant observer, they appear frozen, suspended at the edge of darkness. It's not magic, it's geometry. It's the shape of space and time under extreme pressure. And this leads to an even stranger idea. Time is not something separate from space. They are one thing, spacetime, and movement through one affects movement through the other. The faster you move through space, the less you move through time. The slower you move through space, the faster time flows around you. It's a kind of trade, a balance. If you stood completely still, not moving at all, you'd be moving only through time, 1 second per second. That's the speed most of us live at, but speed up through space and time lets go. Until at the speed of light itself, time no longer passes at all. A photon, a particle of light, is timeless. From its perspective, it is created and it arrives in the same instant. The entire journey is one eternal moment. That's hard to imagine, but you don't have to solve it. Just drift in the idea, because time, that faithful companion, is not fixed. It listens to how you move. It listens to where you are. It bends gently to motion like tall grass in a breeze. And this bending gives us perspective. It means there's no single now. There is no universal moment that stretches across the cosmos. Everyone, every particle, every star, every drifting astronaut experiences time in their own frame. It is deeply personal, and yet it's connected. Because when we compare clocks, we find the truth. We see the stretch. We measure the bend. And we understand that motion doesn't just carry you through space. It shapes your journey through time. You're not trapped in time. You're traveling through it slowly. Surely you're moving forward, but not quite as evenly as you once thought. And perhaps knowing this, you can let go of the idea that time is chasing you. Perhaps instead you're gently floating in it, sometimes faster, sometimes slower, always flowing forward. And as you soften into that thought, let this image hold you. A rocket gliding near light speed. Inside, a traveler closes their eyes. Outside, entire worlds pass. Civilizations rise and fall. Stars burn and die. Butte inside, just a breath, a blink, a soft heartbeat. This is the gift and mystery of time dilation. And it leads to a quiet question. If time can bend for speed, what happens as you approach light itself? What happens when the chase begins? When the dream of catching light reaches its limit? Because next, we'll move closer to that edge, to the boundary that no mass can cross. 2. The moment where time itself begins to break. The chase begins slowly. Imagine it now, gently. You drifting through space in a quiet ship, stars stretching around you like soft silver threads. No noise, no friction, just motion. Smooth and infinite. You start to accelerate. First a little, then more. The engine shum softly beneath you, a vibration more like breath than force. You reach thousands of km/h. Still, Vestars seem distant and still. But soon the rules begin to shift. Not because of speed itself. Speed on its own is simple, but because you're approaching a limit, a wall made not of matter, but of law. You're chasing light. It moves ahead always at the same pace. That familiar steady 299,792 km/s. And you begin to notice something strange. No matter how fast you go, light never gets closer. You push harder. You pour more energy into your motion. Planets cool. Oceans stir. Even the light from distant galaxies stretches as space itself expands, its waves growing longer, softer, more faint. All of it flows forward. So you're not just living in time, you're being carried by it on the soft current of entropy. And maybe in that thought there is peace. Because the arrow of time drawn not with ink but with change means there's always a path ahead. Even when things feel stuck, even when moments loop or linger, entropy is still moving, still pulling you gently toward what comes next. And what comes next is also shaped by heat, by balance, by energy finding its way from here to there. Not in a straight line, but in a quiet pattern. Because entropy isn't just an idea. It's a law that gives birth to heat, to flow, to the very reason things happen at all. In the next chapter, we'll step into that heat. We'll listen to the quiet music of thermodynamics, the deeper rules that shape energy, motion, and rest. Because beneath the arrow of time lies a symphony, and it's still playing. Listen closely. Even now, in the hush of your room, in the softness of your breath, the universe is playing its oldest song. It has no words, no instruments, but its rhythm is everywhere. In cooling tea, in melting ice, in the warmth of your hands against the sheets. This is the music of thermodynamics. Not a melody we hear, but one we live inside. Thermodynamics is the study of energy, how it moves, how it transforms, how it quietly fades into forms we can no longer use. It's the science of heat, of temperature, of systems finding their balance, and at the heart of it again is entropy. But let's begin with something simple. Imagine 2 rooms, one warm, one cold. You open the door between them, and what happens? The warmth spreads, the coolness rises. Eventually, the rooms reach the same temperature. Not by command, but by nature. This is the second law of thermodynamics in motion. Heat flows from hotter to colder, always, not because it must, but because there are more ways for things to be balanced than unbalanced. More ways for molecules to mingle freely than to stand in neat, separated lines. And so, energy spreads. This spreading of energy is the whisper behind everything, from the fire in a star to the quiet hum of your body as it rests. And the rules of thermodynamics don't just guide the stars. They guide you. The food you eat becomes fuel. Energy your cells use to move, repair, think, dream. But not all that energy becomes motion. Much of it becomes heat released through your skin, your breath, your muscles. A warmth that slowly dissipates into the air around you. Even thought has a cost. Each signal between neurons burns just a bit of energy. Microscopic, but real. Every memory you recall, every word you hear now leaves a thermal trace. It's gentle, invisible, but it's always happening. Energy flows, and in flowing it changes. This is the first law of thermodynamics. Energy cannot be created or destroyed. It can only change form from potential to kinetic, from chemical to thermal. The total amount of energy in the universe stays the same, but how we use it, that's where the laws take hold, because energy tends to move from useful to less useful forms. It becomes more spread out, more difficult to gather. You can burn wood to boil water, but you can't unboil water to remake the wood. The process is one way, and in that own way street, we find a quiet, inevitable loss, not of energy itself, but of its usefulness. This is why machines wear down, why engines need fuel, why stars eventually go dark. It's not a flaw, it's a flow. Think of it like a waterfall. Energy begins at a height, concentrated, directed. As it falls, it spreads, it churns, it cools, and when it reaches the bottom, it's still there, just no longer able to drive the wheel. This is the third law of thermodynamics, whispering from the edge, telling us that as temperature approaches absolute zero, entropy approaches a minimum. But that perfect stillness, that perfect order, can never quite be reached. There will always be some motion, some jitter, some trace of randomness. And so the music plays on. The universe began with immense concentrated energy, and ever since it has been unwinding slowly, beautifully, not into silence, but into complexity, into change. Because this unfolding of energy makes space for stars to shine, for planets to form, for life to emerge. Without thermodynamics, there would be no warmth, no breath, no flame. It is not a science of endings, but of becomings. And when systems reach balance, where no more energy can be usefully extracted, we call that equilibrium. It is stillness, not in the absence of motion, but in the presence of perfect sharing. Equilibrium is what your tea finds when it reaches room temperature, what your body finds when it rests after a long day, what the earth slowly moves toward in every cycle of weather and time. But balance is never permanent. Systems open again. Energy enters. The dance continues. And the most elegant part of this dance is that it's not random. It follows rules. 4 main laws that bind thermodynamics together, like verses in a poem. Zeroth law. If 2 systems are each in thermal equilibrium with a third, they're in equilibrium with each other. This is how we define temperature. A shared language of heat. First law, energy is conserved. It changes form, but nothing is lost. Second law, entropy increases. Systems move toward equilibrium. Heat flows from warm to cool. Third law, as temperature approaches absolute zero, entropy approaches its lowest possible value. These are not laws written by hand, but truths observed by the universe itself. You feel them when you warm your hands by a fire, when your phone gets hot after a long call, when your breath fogs in the cold air and disappears. And these laws shape not just matter, but time. Because as energy flows, entropy rises, and the arrow of time continues to point forward always. There is no wind in thermodynamics, no return to perfect order, only transformation, only exchange. And in that, there is great beauty. You're not separate from this. You're thermodynamics in motion, a system that eats, thinks, sleeps, dreams. A body that converts energy into warmth and motion, and in turn gives it back softly to the world. Even now, as you rest, your body releases tiny threads of heat to your sheets, to the air, to their stars, if you could see far enough. You're part of the symphony, not just hearing it, but playing it. And like all music, it flows forward, which brings us slowly, gently, to a grander scale. What happens when the very fabric of space and time begins to stretch? What happens to this thermal flow, this entropy, when the universe itself is expanding? In the next chapter, we drift outward beyond your room, beyond your planet to watch the cosmos breathe, to see how expansion carries energy, entropy, and light toward a future written not by hands, but by space itself. Even the stars don't mirror each other. You might think the universe, vast, ancient, precise, would prefer symmetry, that it would echo itself like reflections in a quiet lake. But the deeper you look, the more you find small imbalances, slight shifts, patterns that lean one way and not the other. And in these tiny broken symmetries, the universe reveals its deepest truths. You see, physics loves symmetry. It builds its rules from balance, from the idea that if you change something, but the laws stay the same, that symmetry has power. Rotate a circle, flip a snowflake, change a clock from 30 to 3:01. If the rules still hold, symmetry lives. But the universe is not perfectly balanced. And that is everything. Take, for example, the speed of light, that sacred, unbroken limit. It's not just fast. It's not just constant. It's protected by the laws of physics. But what gives it that protection? One answer lies in symmetry and how it breaks. Let's begin with something gentle. A flat pond. When undisturbed, it's perfectly still. You could reflect the sky in it, rotate it, and nothing changes. But now, toss a stone. Ripples spread. Movement begins. Suddenly, some directions matter. Time matters. Before the splash and after the splash are not the same. Symmetry is broken. And in that break, information is born. In the early universe, right after the Big Bang, everything was hot, dense, and uniform, nearly symmetrical in every direction. But as it expanded and cooled, that symmetry began to break. Just like crystals, forming in water, the universe chose a shape, a direction, a set of laws. From that quiet shift, the speed of light emerged, not as a guess, but as a consequence. Because when you break a symmetry in physics, you often get a constant, a value that holds steady, a rule that remains even as the world changes. It's like choosing a key in music. Once chosen, all the notes find their place around it. This is how the constants of nature, like the speed of light or the strength of gravity or the charge of an electron, are thought to emerge. They are the remnants of deeper symmetries gently broken, softly remembered in every atom. But not all symmetries are broken equally. Some seem to hold. For instance, Lorentz symmetry. The idea that the laws of physics are the same no matter how fast you're moving or which direction you're facing protects the speed of light itself. It tells us that no matter your frame of reference, light will always pass by at the same pace. And yet, even here, researchers test for cracks. They build experiments so delicate, so precise, they can sense the tiniest tremble. They ask, what if the symmetry isn't perfect? What if the speed of light varies by a billionth of a billionth depending on direction? So far, they find nothing. Just silence. Just stillness. The symmetry holds. But other symmetries break easily, like par. The idea that nature doesn't prefer left or right. In most physics, flipping space shouldn't matter. But deep in the world of particles, this rule breaks. Some decays favor one direction, like aspinning, coin, always choosing the same side. This subtle bias may be why matter exists at all. Because when matter and antimatter were created in the early universe, they should have existed in equal amounts and annihilated each other completely, but they didn't. Something tipped the balance, a tiny asymmetry, a slight preference. And that leftover matter, it became everything. Every tree, every book, every sleeping body beneath a sky full of stars. You are here because symmetry broke. And this same breaking, this same quiet decision the universe once made helps define their limits we now live within. It defines why the speed of a light doesn't vary, why energy follows certain paths, why time has a direction. Imagine a snowflake, forming, symmetrical in all directions, but one branch grows faster, just a little. And from there, the pattern changes. One choice leads to another, and the balance shifts forever. The cosmos is a snowflake mid-formation, and here's a thought to hold in your hands. Symmetry breaking is not a loss of beauty, it's a creation of structure. Without it, nothing can form. No difference means no shape. No choice means no time. It's the same with music. A perfect tone held forever is not a song. But break that tone, shift it, repeat it, bend it, and melody emerges. The universe is full of melody, and you lying here now are shaped by those notes. The asymmetry in your hands and feet, the preference in the spiral of your DNA, the left-right curve of your heartbeat, all born from ancient imbalances, from the moment the universe stopped being still and began becoming real. These asymmetries ripple outward, still unfolding. They allow rules to form, limits to exist, and one of the greatest of those limits is the speed of light. The boundary that marks what can be touched and what must be watched from afar. It stands firm, not out of stubbornness, but out of symmetry. Out of the quiet decision the universe made. In its first seconds, when space took its shape and time found its direction. So as you breathe now slowly and warmly, think of this. You are cradled in a cosmos where the rules are precise but not perfect. Where every law is born from a symmetry slightly cracked like light through a crystal splitting into color. And that color is everything you see, feel, remember. Soon we'll step further into that cosmic shape, not through rules and constants, but through movement, through the stretching of space itself. Because the universe is not just filled with energy, it is expanding. And as it expands, the old balances shift again. Light stretches, time lengthens, energy spreads. Next, we follow that stretch into the breath of the cosmos. Breathe in. Now, slowly breathe out. Feel the air move. Feel your ribs soften. That rhythm, expansion and release, is the same rhythm written into the fabric of the cosmos. The universe too is breathing, not in and out, but only outward. Space is stretching quietly, gently, constantly. You can't feel it from here. The expansion doesn't pull at your arms or your skin. It doesn't shake your bed or push the walls apart. That's because gravity holds you together. Your body, your room, your planet. But between galaxies, the space is growing, not like galaxies flying away through the air, not like specks moving through something bigger. It's space itself that is unfolding like dough rising in a warm oven. The galaxies ride this dough, not moving on their own, but drifting apart as the fabric beneath them expands. And it has been doing this since the very beginning. The moment the universe began, in the birth we call the Big Bang. It started expanding not from a point in space, but of space. There was no outside to burst into. There was only stretching, and it hasn't stopped. In fact, it's speeding up. This discovery came quietly, almost by surprise. In the late 1990s, astronomers, studying distant supernova, bright dying stars used as cosmic yardsticks, noticed something strange. The light from these supernovae was fainter than expected. Too faint, as if they were farther away than they should be. The only explanation, the universe's expansion was accelerating. Not only was space stretching, it was doing so faster and faster with time. Something unseen, something quiet and vast was pushing everything apart. We call it dark energy. No one knows exactly what it is. It isn't a force in the traditional sense. It doesn't come from a particle we can touch or trace. It's more like a pressure built into space itself, a tendency to stretch, a whisper between stars. Dark energy doesn't rip things apart close up. It doesn't tear atoms or galaxies, but over the great distances between galaxy clusters, it becomes dominant. It tugs gently, evenly, everywhere. And so, the universe expands faster and faster. This means that galaxies far enough away aren't just drifting, they're receding at incredible speeds. In fact, beyond a certain distance, galaxies are moving away from us faster than the speed of light. Does that break the rules? Not quite. Remember, the speed of light limit applies to objects moving through space. But when space itself expands, that rule bends. It's as if the floor beneath you is stretching, carrying things farther apart without anyone running. So galaxies aren't flying away faster than light. They're being separated by the stretching fabric between them. And the farther you look, the more stretched that space becomes. This is why the light from distant galaxies looks redder, stretched into longer wavelengths. It's called cosmological redshift. Not because the galaxies are speeding away in the usual sense, but because the space between us and them has grown, while their light was in flight. That light, ancient and patient, was born billions of years ago. Since then, the space it travels through has stretched, and the light has stretched with it. It arrives now softened, whispering stories from the early universe. So every photon you see from a distant star is not just a message across space, but across time. And as space expands, time stretches too. Not in a way that changes your clock or your breath, but in the grand cosmic rhythm. The beat between moments grows longer. The time between galaxies, between events in the distant past and now, becomes softer, more spread. It's as if the universe is relaxing, not slowing, but opening. More room, more distance, more time. And yet, even this stretching has its structure. The expansion may feel gentle, but it shapes the fate of everything. There was a time when people thought gravity might slow the universe down, pull it back inward like a rubber band snapping after a stretch, a big crunch. But with dark energy accelerating, the growth that future seems unlikely now. Instead, we look ahead to a universe that will grow ever larger, ever emptier. Galaxies drifting so far apart that their light can never reach us. A sky that dims, not from nightfall, but from cosmic isolation. It won't happen soon. Not for billions upon billions of years, but the path has been set. And yet, here you are. In the midst of this gentle acceleration, you exist. A brief, luminous pause in the vastness, breathing, thinking, wondering. Even as galaxies recede and stars soften, your life burns with presence, a small warmth in the grand unfolding. And this brings us to something quiet and wondrous. Why does space expand at all? We don't know for certain. We can measure it. We can describe it. But the deep reason, the why, still slips through our fingers like mist. Perhaps it is built into the very equations that govern gravity and energy. Perhaps it is a leftover ripple from the beginning, from inflation, that brief and unimaginable surge in the first trillionth of a second. Whatever the cause, expansion gives the universe its shape. It gives time direction. It gives light a path. It gives matter a place to gather, to cool, to become stars and planets and thoughts. Without expansion, there would be no night sky, no galaxies, no distance to wander at. And as you lie here now, resting in your own quiet orbit, know that space itself is stretching beneath you. Not enough to pull you, not enough to separate your atoms, but enough to remind you nothing in the universe is static. Even emptiness evolves. Even silence expands. And beyond all this gentle motion, there are stranger places. Still, places where space folds more sharply than it stretches, where time slows to a crawl, where even light cannot escape. Because next we drift toward the edge of a black hole, to the dark heart of gravity's deepest secret. Now drift deeper. You floated through expanding space, through the gentle pull of entropy and the silent stretch of light. But not all space expands evenly. Some places do not open. They collapse. Tonight, we fall into one of them. We fall, not with fear, but with wonder, toward a black hole. A place where time folds in on itself, where space curves so sharply, even light cannot find its way back. Out, a place not empty but full of gravity, full of silence, full of mystery. Black holes are not monsters. They are not rips or holes in space. They are regions of intense mass and dense reality, the collapsed cores of massive stars compressed into a point of unimaginable gravity. To form a black hole, a star must burn long and large. It lives brightly, fusing hydrogen into helium into heavier elements. But when its fuel runs out, gravity wins. The outward pressure of heat fades, and the star folds inward, pulled by its own mass. If the star is massive enough, no force can stop the collapse. Not atoms, not light, not time. And a black hole is born. The edge of a black hole is called the event horizon. Not a surface, but a boundary. Once crossed, nothing returns. Not because it's destroyed, but because the paths all point inward. Like rivers running into a whirlpool, all trajectories bend toward the center. From the outside, this horizon looks like a shadow, a perfect sphere of absence, but it is not hollow. Inside, the mass of the collapsed star still exists, concentrated into what we call a singularity, a place where space and time are infinitely curved. And here is where things grow strange. As you approach the event horizon, gravity grows stronger. Your clock ticks more slowly compared to someone far away. Your steps stretch. Your thoughts seem to lengthen. Time dilates. If you hover just outside, the edge, a feat that would require unimaginable energy, you would witness the universe speeding up, stars whirling, galaxies spinning, the future unfolding and fast forward. And if someone watched you from afar, they would see you slow down. Your motion would stretch toward stillness. You would appear frozen, suspended at the edge forever, never quite crossing. But from your perspective, you fall freely. There is no edge, no barrier, only a smooth continuation inward toward the singularity. And yet, we do not know what happens at that singularity. Our equations fail. Gravity becomes infinite. Space-time loses its meaning. The very fabric of the cosmos unravels. Some believe that inside a black hole, the rules of physics rewrite themselves. That space becomes time. That time becomes space. That somewhere beyond the singularity, another universe might begin. Others think information, the structure of what falls in, is not lost, but somehow encoded on the event horizon, like shadows on a wall, a kind of cosmic memory. This is the black hole information paradox, a mystery still unsolved. Because in the world of quantum mechanics, information cannot be destroyed, but black holes seem to erase it. What happens to the matter that falls in? What happens to the pattern, the structure, the identity of what was? Stephen Hawking once proposed that black holes might slowly evaporate, releasing particles over immense time, shrinking until nothing remains. This is called Hawking radiation. But if the black hole fades, where does the information go? Does it escape? Is it stored? Or is it truly gone like breath in the wind? These are not just riddles for scientists. They are questions about the very nature of reality, about whether the universe keeps its memories, about whether the past is preserved even in the deepest gravity. But for now, the black hole holds its secrets. We can't see inside, but we can feel its presence. In 2015, scientists detected gravitational waves, tiny ripples in spacetime created by two black holes colliding more than 1 billion light-year away. Like pebbles dropped in the cosmic pond, their merger sent vibrations across the universe, and we heard them, not as sound, but as motion. Delicate shifts in detectors, smaller than a fraction of an atom. These waves confirmed Einstein's prediction. They proved that black holes are real, not just theory, that the universe does move and flex and sing with gravity. And in 2019, we saw the unseeable. Astronomers captured the first image of a black hole's shadow, not the hole itself, but the glow of matter swirling around it just before falling in. A glowing ring, a silhouette of the infinite. That image was history, not for its pixels, but for what it meant. It meant we can witness the edge of time. You lie here now, surrounded by calm, but out there, light is being bent into perfect circles. Time is being stretched into silence. Matter is being written into the deepest archives of the universe. And yet, black holes are not voids of destruction. They're part of the story. They anchor galaxies. They recycle matter. They shape space. They obey the laws of thermodynamics with entropy and temperature of their own. They are not just ends. They are transitions. Because even a black hole, as strange as it is, still listens to the universe's rules. It doesn't break the speed of light. It bends the paths around it. It curves time, but doesn't escape it. It holds its form until it fades. So as you drift towards sleep, imagine yourself not falling into darkness, but orbiting it, dancing around the edge of the unknowable, feeling the tug of mystery, letting it pull your thoughts into deeper stillness and then float outward again. Because not everything that moves through the cosmos is heavy. Some things are weightless, timeless, made of pure energy. Next, we travel with them with photons, the smallest packets of light. Messengers that never rest, particles that never age. To understand time, we must learn to see from the point of view of light itself. Now, we leave the curves of gravity behind. We rise from the edge of black holes, out of the deep wells of folded time, and step into something lighter, something that doesn't bend time, but simply moves through it, or perhaps beyond it. Tonight we travel with photons, tiny packets of light, gentle messengers of energy, no mass, no rest, no aging, no waiting. They are the children of stars and the silent record keepers of the cosmos. They have seen everything, not because they remember, but because they're memory, and they are always in motion. You've met light before in the warmth of the sun, in the glimmer off, fireflies, in the glow of screens and candles. But those familiar lights are just the beginning. Most photons are not visible. They move as infrared, as radio, as X-ray, as gamma, parts of a spectrum too wide for our eyes to hold. But all photons share one truth. They always travel at the speed of light. Exactly. Always. This isn't just a feature. It's who they are. A photon never slows down, never stops. It can't. To stop would require mass, and photons have none. They are pure motion, and because of that, they live outside the usual flow of time. This is where things get curious. From your perspective, A photon's journey might take minutes or years or billions of years. A beam of starlight that leaves its source tonight might not reach Earth for millennia. It travels faithfully without pause, but from the photon's point of view, no time passes at all. There is no journey, no waiting, no distance. It is emitted and it arrives in the same breathless instant. For a photon, the universe is compressed into a single point. There is no separation between here and there, before and after. It doesn't feel the journey, it is the journey. And this idea that light experiences no timer shapes how we understand motion. When you walk, you move through space, but you also move through time. The faster you go through space, the slower you move through time. It's a trade. One gains, the other gives. Photons take this to the extreme. They move only through space. Zero through time. Their speed, the speed of light, is not just a maximum. It's a perfect balance point where time stops flowing for the traveler. That's why we say photons are timeless. They carry energy. They interact. They are born and absorbed, but they do not age between. This is not just metaphor, it's physics. When light leaves a distant galaxy, it does not feel the weight. It stretches. Yes, its wavelength grows with the expanding universe, but the photon itself is not delayed. It simply travels unwavering, unwearied. And that journey makes you possible. Every sight you've ever seen, every image, every color, every star in the sky, all carried to you by photons. Without them, there would be no vision, no warmth, no knowledge of the wider world. You owe your days to their timelessness. Even now, as you lie still, photons are passing through you from distant sources, from nearby lamps, from the faint glow of the cosmos. They pass through your skin, your room, your memories. Some have traveled from the far edge of the visible universe. Some were created seconds ago. All move the same. All carry fragments of energy, parcels of possibility. And though they have no mass, photons do have momentum. This is what makes solar sails work. Vast sheets launched into space, catching sunlight the way a boat catches wind. The photon's push is tiny, but it's real. Given time and distance, that push adds up. Even the faintest starlight can move a ship, gently if we'll learn to listen. Photons also carry information encoded in their frequency, in their direction, in the way they're scattered or absorbed. When light bounces off an object, it carries thestory of that object, its shape, its color, its motion. That's how telescopes read the stars, how satellites map distant galaxies, how we see anything at all. Photons are our only bridge to the past. They show us not how things are, but how they were, because they take time to reach us, even though they themselves don't experience it. So when you gaze at the sky, you are seeing ancient light, the moon, as it was 1 second ago, the sun, 8 minutes ago, Sirius 9 years ago, and some galaxies billions of years past. The night sky is not a picture. It is a memory, a glowing silent archive of what has been. And yet photons are not only quiet witnesses. They are playful too. In the world of quantum physics, they can behave like waves and particles. They can interfere, diffract, entangle. A single photon can take multiple paths, a tons, until observed when the possibilities collapse into one. This strangeness is real. It has been tested, measured, confirmed, and still it invites awe. How can something so small, so fleeting, be so complex? Perhaps because complexity isn't about size or team. It's about connection. Photons connect. They link stars and eyes, fire and warmth, thought and light. Every communication, every color, every image you've ever known comes down to these tiny threads. And while they never stop to rest, they do eventually end. A photon is either absorbed, its energy taken up by an atom, a surface, a sensor, or scattered, deflected on a new path. Its journey ends not in exhaustion, but in exchange. Its energy becomes something else, a spark, a signal, a thought. So even though a photon doesn't age, it still completes a life, one that begins with release and ends with arrival. A journey through the cosmos, timeless yet full of meaning. And maybe in a small way, We're like that too. We move through time, yes, but we also send out parts of ourselves, words, ideas, light, energy, things that travel far beyond us, that ripple through space long after we are still, things that do not tire, things that, like photons, carry warmth into the cold. And now we drift with them, weightless, endless, full of motion. Because light, for all its speed, is patient. It will travel across the universe if it must, with no complaint, no pause. And in doing so, it illuminates the way. But as we float with light, we begin to wonder, what is rest? If light cannot stop, what does it mean to stand still? To move not through space, but only through time. In the next chapter, we'll return to that stillness, to you lying, motionless, in space, but racing through time. You lie still now, your breath soft and slow, your body wrapped in quiet. Nothing rushes, nothing presses, and yet you are moving not through space, but through time. At every moment, even in your deepest stillness, you're drifting forward second by second, carried on a current you cannot feel. You're not lost, you're not late, you're simply following the river of time. And in this gentle drift, there is a truth. Stillness and motion are not opposites. There are two ways of experiencing time. Let's begin with perfect stillness. Imagine for a moment you are suspended in space. No gravity, no friction, no sound, not orbiting, not spinning, just there, motionless. In this perfect stillness, you move through time at your full natural pace. Your clock ticks forward second by second. Your thoughts unfold as they always do. Your body follows the familiar rhythm of rest, of breath, of dreaming. This is your proper time. The time felt by you, measured by your own clock, ticking in step with your heartbeat. But the moment you begin to move, really move at speeds approaching, light, your experience of time changes, not because something breaks, not because your clock is wrong, but because time itself stretches. You felt this truth in earlier chapters. The faster you move through space, the slower you move through time. It's a kind of trade, as if the universe gives you more distance in exchange for less duration. And if you could reach the speed of light, though you can't, time would stop completely. A photon does notage. It travels across galaxies in what to it is a single moment. You with mass and memory will never feel that. But the concept still holds meaning. Motion shapes time. Stillness allows time to pass at full measure. That's why in your quiet rest now you are experiencing something essential. You're aligned with the natural rhythm of time. Not slowed, not stretched. Simply moving forward at the same speed as the universe around you. Not faster, not slower. A kind of resonance. And here's the strange and gentle paradox. Even though you're not moving, you're aging faster than someone racing through space. Not by much, not enough to notice, but measurably. Time is passing for you a little more swiftly than for an astronaut to board the International Space Station, zipping around the Earth at 28,000 km/h. They move more through space, so they move slightly less through time. They return to Earth younger by milliseconds. This effect becomes dramatic at higher speeds. At 90% the speed of light, time slows noticeably. At 99%, the world outside rushes ahead. At 99.9999%, entire years can pass for those at rest, while the traveler experiences only days. And still from their perspective, everything feels normal. Each observer sees their own clock tick evenly. Each person feels grounded in their own now. There's no universal center, no master clock ticking for all. Time is personal, but relationships between times, that's where motion matters. And this reveals something profound. Rest is not a lack of movement. It's a special kind of alignment. When you are at rest, truly at rest relative to your surroundings, your experience of time is undisturbed. You're not bending it. You're not trading it. You're flowing with it. And when you move, that flow changes. You tilt time slightly, not in a wrong direction, but in a different one. A path across the fabric. of spacetime that takes you through space faster and through time more slowly. It's like choosing a different slope on a hill. All paths move downward into the future, but some take longer routes through the landscape. Now consider the Earth itself, spinning, orbiting, moving through the galaxy at immense speed. Even as you rest, you're not still in the grand sense. You're flying around the Sun at 30 km/s. The Sun itself moves through the Milky Way at 220 km/s, and the galaxy drifts through the universe even faster still. But these motions are shared. You move with the planet, with the solar system, with the stars. These shared paths mean you are not moving relative to them. You're still part of their rhythm. That's why your experience of time feels steady. It's only when you move relative to your surroundings, to other frames of reference, that time begins to stretch. So what does rest mean in a universe that's always in motion? It means co-motion, harmony, moving with, note against. Right now, your body is resting in the Earth's gravity. Your atoms are not resisting the planet's curve in spacetime. You're in free fall technically, held gently against the surface by the planet's mass. Your time flows naturally here without strain. This is a peaceful place to be. And rest is not just physical, it's mental, emotional, temporal. When you rest your body, you give your mind a moment to soften. When you pause from activity, you stop accelerating. You stop tilting your time. You allow it to move through you uninterrupted. There is a comfort in that, a sense of returning to the center, the still point around which all motion revolves. You're not lost in time. You're not late. You're exactly where you're meant to be, at rest in the universe's unfolding. So as you breathe now, know that you are moving through time at full pace, that every cell in your body is experiencing its own rhythm, that your dreams, when they come, will follow their own gentle arc through this moment. And even as you lie still, energy pulses within you. Thoughts flicker, blood flows, heat drifts outward. Tiny motions echo through your cells. You're both motionless and in motion, a paradox, a harmony. And now rest becomes even more profound because soon we'll explore how the tiniest parts of you, your cells, your molecules, your very structure, also shift and change. Not through motion in space, but through motion within. We'll drift inward, now to the entropy inside your body. You are made of stars and of their ashes. And like the universe itself, you're never truly still. Even in sleep, even now, your body is changing quietly, gently, inwardly. Entropy flows through you, not in chaos or destruction, but in warmth, in balance, in change. You're a living system full of order and full of motion toward disorder. A small, temporary miracle of structure in a world that tends towards scatter. Let's begin with warmth. Place your hand on your chest. Feel the soft rise and fall. Beneath that rhythm, trillions of chemical reactions are taking place every second. Cells exchanging energy, proteins folding, neurons firing. Every one of those reactions releases just a little heat. It's not wasted. It's not wrong. It's entropy. Energy moving toward more freedom, toward more evenness. That warmth on your skin is a signature of life and of change. A message that your body is active and that its energy is always seeking balance. Your body is not closed off from the universe. It exchanges constantly heat, breath, matter, thought. And in every exchange, entropy plays its quiet role. Because every action your body performs comes at a cost. You eat food. Your body breaks it down, harvesting energy from chemical bonds. That energy helps you move, think, laugh, heal. But not all of it becomes emotional memory. Much of it becomes heat released through your skin, your breath, your size. The order in food becomes the disorder of warmth, entropy. But this is not a loss. It's a flow, a necessary part of being alive. To live is to create temporary order and to release energy in doing so. Even your thoughts create entropy. Your brain is a hungry organ. It uses a fifth of your body's energy just to keep thinking. Every idea, every memory, every dream comes with molecular movement, electrical pulses, chemical changes. Your neurons burn glucose. They pass ions through delicate channels. And in all of this, heat escapes, slight, invisible, but steady. Even dreams cost energy. And when they fade, they sometimes leave no trace. A forgotten thought, a vanished image. Entropy isn't just physical. It lives in memory too, in the soft erosion of sharp edges, in the way moments blur over time. Forgetting is entropy of the mind, not a failure, a function, because the brain cannot keep everything. It is a balancing act between order and change, between structure and flexibility. A low entropy brain would never forget, but it would also never adapt, never learn, never make room for something new. So you forget. And in doing so, you evolve. Even your cells, the smallest pieces of you, obey entropies, pull. Proteins fold into complex shapes to do their jobs. But sometimes they misfold, or become tangled or degrade. Your cells have mechanisms to repair this. Enzymes that sort and refold. Systems that clean and recycle. But the balance is never perfect. Over time, entropy builds. Tiny errors accumulate. Structures wear. This too is part of aging. Not as a sudden failure, but as a slow and natural release of order. Yet life resists entropy, not by stopping it, but by working within it. Your body uses energy to maintain itself, to rebuild, to regulate, to preserve, structure against the pull of disorder. You're constantly pushing back the tide molecule by molecule. This is why you need sleep. Sleep is not just rest, it's repair. During deep sleep, your brain performs a kind of nighttime housekeeping, clearing waste, resetting patterns, consolidating memory. Energy is redirected inward. Order is restored gently where it began to fray. And even this process creates entropy. Even repair has a cost, but that cost is what makes renewal possible. You are in a sense a fountain of moving energy, drawing from food and air, rearranging molecules, sending signals, releasing heat. Entropy is the price of transformation. And still, despite the pull of entropy, you are more than a system drifting towards stillness. You're full of patterns, of memories, of meaning. Life is not just about resisting disorder. It's about weaving it into something rich and temporary and beautiful. Consider your heartbeat. It is not perfectly regular. It fluctuates subtly from beat to beat, a kind of controlled variation that signals health. Too much rhythm and the heart is brittle. Too little and it's chaotic. Health lies in balance. The same is true for thought. Creativity requires disorder. New ideas emerge from rearrangements, from entropy as much as from discipline. Even your emotions follow this pattern. You move between states: joy, sorrow, calm, hope. Each shift is a change in chemical balance, in perception, in attention. Each one costs energy, each one helps you adapt. You're not a machine, you're a flow, and entropy is part of that flow. Without it, nothing would change. No thought would form, no breath would move, no dream would evolve. In fact, your very birth, your existence was made possible by entropy. The egg and the sperm that formed you were high in order, but together they released energy. That spark of creation began a cascade of molecular change, of structure, of growth, of entropy spreading even as life took shape. And one day, long from now, your body will return to the earth. Its molecules will scatter, its energy will diffuse, its shape will dissolve, not an end but a continuation. The entropy of your body will feed the order of something else, a tree, a breeze, a cycle older than memory. You're part of a process, not separate from the stars, but made of the same dust, following the same rules. And as you rest tonight, feel that connection. Your warmth is not wasted. It is part of the unfolding. Even as you lie still, the entropy within you hums softly, patiently, like a lullaby from the universe itself. And now we lift our gaze outward again, because just as entropy shapes your body, it also shapes the sky. It shapes the stars themselves. And next, we'll listen to the quiet, changes in the heavens, to how stars burn, how they balance, and how even their brilliant order cannot last forever. Close your eyes. Let your breath settle. Let your thoughts fall like dust through sunlight. And imagine, if you can, the beginning of everything. Not a bang, but a bloom. The universe began not in violence, but in light, in heat, in possibility. A tiny moment, dense, bright, almost unspeakably hot, where everything that would ever be was cradled together, tightly wound like a seed just before spring. This was the early universe, a place where energy moved wildly, where particles collided, merged, danced, separated, where time had barely begun to tick. It was full of light, full of fire, and full of order. That may seem surprising, but the early cosmos in all its chaos was incredibly smooth. Temperature nearly the same everywhere. No galaxies yet, no stars, just a uniform glow, dense and balanced, low in entropy. And then it expanded. Space stretched. The energy within began to cool. The glow softened. Patterns began to form. Small fluctuations, tiny ripples in density, seeds of future galaxies. Entropy began to rise, and the universe in its quiet unfolding began to cool. This is the long arc of cosmic time, a journey from heat to cold, from tight light to wide darkness, from the birth of fire to the fading of stars. But cooling is not a failure. It is the natural gift of time and motion. When energy spreads, it becomes less concentrated. That's the heart of cooling. Energy becoming less focused, less available, more shared. The heat doesn't disappear. It moves outward, thins, relaxes into space. And the more space there is, the more room for energy to spread. The universe expands, and so it cools. The ancient fire, once so close and fierce, becomes a soft background hum. Even now, that glow is still with us, a whisper from the beginning, known as the cosmic microwave background. It fills all of space, faint and cold, just a few degrees above absolute zero. It is not bright, not warm, but it is still here, a fingerprint of the universe's youth. And every star, every galaxy, every planet that has formed since then carries a little of that cooling within it. Stars, for example, burn with ordered energy. Hydrogen fusing into helium, releasing light, heat, motion. But that order comes at a cost. Entropy rises. The heat radiates outward, never to return. Eventually, the fuel runs low. The star ages, expands, contracts, and dies. Not in darkness, but in transformation. Some stars end in quiet puffs of gas-like candles fading. Others go out in blazing supernovas, scattering heavy elements, carbon, oxygen, iron, into space. And then they leave behind remnants, white dwarfs, neutron stars, or if massive enough, black holes. But even those remnants are cooling. A whiter dwarf, bright at first, slowly dims over billions of years. A neutron star radiates its energy like a forgotten ember. Even black holes may evaporate over unimaginable timescales, releasing tiny amounts of radiation into space. All roads lead to stillness, but this stillness is not silence. It is balance. The universe is not rushing toward death. It is drifting toward equilibrium, a state where energy has spread as evenly as it can, where there are no sharp differences. No hot or cold, no up or down, just a soft, even hum. This future is sometimes called the heat death of the universe. Though the name is misleading, there is no explosion, no collapse, just a long quiet fading, a release. And it is not sad, it is serene, because even in cooling, the universe creates. As energy spreads, structures emerge, stars form from collapsing gas clouds. Planets coals from dust. Life arises in warm temporary niches, brief flames in a cooling night. Without expansion, without entropy, Without cooling, none of it could happen. You wouldn't be here. So this cooling isn't a flaw. It's a feature. It gives time its shape. It gives matter its chance. Even your body, your thoughts, your memories are possible only because the universe did not remain hot and uniform. Because it changed. Because it allowed room for structure to form and for that structure to slowly release its heat. You are in a sense a local exception. A warm flicker in a universe growing cold. But your warmth is part of the process. You radiate heat. You release energy. And slowly, gently, you too are moving towards stillness, one breath at a time. But this motion is not linear. In small corners of the universe, cooling allows complexity. It allows gravity to pull together stars. It allows atoms to bond. It allows life to think and feel and dream. Entropy increases, yes, but in that rising tide, small islands of order arise. Your body is one such island. Earth is another, and across the universe these islands rise and fall, always temporary, always shaped by the cooling background. They are not separate. They are part of the drift. So as you rest now in your quiet space, feel the gentle presence of that drift. Your warmth softly rising into the air is a note in the universe's great exhale. And the cooling that surrounds you, the dark between the stars, is not a void, but a canvas. A place where motion fades and softness begins. And yet before the universe cooled, before stars formed, there was a moment when light could not move freely. When photons were trapped in a dense fog of particles, when space was hot, thick and bright, but no image could escape. Next, we'll drift back to that hidden age, to the time when light was held close, to the moment before the first sunrise, long before stars, long before galaxies, before planets and oceans and questions like yours. There was only light, but it couldn't go anywhere. It was trapped, tangled in aethic fog of matter, bouncing endlessly, absorbed and remitted again and again. A cosmic game of hide and seek that lasted for nearly 400,000 years. Tonight, let's float back to that moment, not to the Big Bang itself, but to what followed, to a universe still glowing, still expanding, still finding its rhythm. This early universe was unimaginably hot, so hot that atoms couldn't yet form. Protons and electrons darted freely, unable to stay together, and light photons was caught in this charge soup, constantly colliding, constantly scattered. It's called a plasma. Not solid, not liquid, not gas, but a fourth state of matter, full of energy, full of motion, and completely opaque. This was a time when the universe had no transparency, no shadows, no vision. If you'd floated there and somehow survived, you wouldn't have been able to see even your own hand held out before you. Not because it was dark, but because it was too bright and too scattered. Light existed, but it couldn't travel. It was always being absorbed, knocked off course, trapped by the ever-present particles in its way. And then slowly, everything began to cool. As the universe expanded, the temperature dropped. The furious motion of particles began to soften. And, after hundreds of thousands of years, a moment came quiet, miraculous, when things began to settle. Electrons slowed enough to be captured by protons. And at last, atoms were born. Mostly hydrogen with a touch of helium. This moment is known as recombination. Though the atoms weren't recombining, they were forming for the first time. The term comes from the equations, not the poetry. And when atoms formed, something extraordinary happened. The universe became transparent, because neutral atoms do not scatter photons the way free electrons do. Suddenly, light had room to move. It was released like a breath long held. This release is called decoupling. The moment when matter and radiation parted ways, each going their own direction. And the light that burst forth in that moment, it's still traveling, still moving through the universe. It has stretched with space, softened, with time, cooled to a gentle hum, but it's still there all around you in every direction, a sea of ancient light. This is the cosmic microwave background. The oldest light we can see, the afterglow of that first great clarity. It's not a single beam or flash. It's a background, a low uniform signal that fills the entire sky. Discovered in 1965 by accident by two scientists investigating radio noise. It became one of the most important clues to understanding the birth of the cosmos, because in that faint glow we can see patterns, slight variations in temperature, in density, tiny ripples, just a few parts in 100,000 that would one day grow into galaxies, clusters, stars, and planets. You're made of those ripples. Your body, your world, your story, all seeded in the moment when light was set free. And this light, this cosmic background, doesn't illuminate in the way a lamp does. You can't see it with your eyes, but it can be measured, mapped, understood. It forms a kind of snapshot, a baby photo of the universe. Looking at it is like peering across time into a moment when everything was young and glowing. And the wonder is this. The universe from the very beginning carried within it the structure to become what it is now. The same laws, the same constants, the same quiet drift toward complexity. All that was needed was time and cooling and that first breath of light. Imagine it now, the universe filled with soft golden haze. Then suddenly, it clears. The light moves outward. The fog lifts and space for the first time becomes something you could look across. Not that there were any eyes to see it. Not yet. But if there had been, it would have been like watching a sunrise over everything. And that light has never stopped moving. Billions of years later, it still streams across the sky. Not as brightness, but as presence. As a memory. It fills your room now, just as it fills the vacuum between galaxies. Not warm enough to feel, not bright enough to notice, but constant, patient, persistent. A reminder of the moment when the universe first became visible, and from that moment forward, light became more than just energy. It became messenger. It traveled from stars, from distant galaxies, from exploding supernova and forming planets. It began to carry stories, and we began to learn to read them. All because the fog cleared. All because atoms held hands for the first time and let the light go free. And that moment, so ancient, so small, still shapes everything. Because it taught the universe to be seen. It gave space its depth. It gave vision its meaning. Even now, every time you see light, a sunrise, a candle, a distant star, you are touching a tradition that began in that first great decoupling. A light once trapped, now free. And next, we listen for what came just after. Because even after the fog lifted, the light that travelled carried an echo, a pattern, a whisper of everything that came before. In the next chapter, we'll hear that whisper. We'll follow the echoes of the Big Bang. Let's listen now, not with ears, but with quiet imagination. Not for a song or a voice, but for a soft echo. One that's been travelling through the universe for nearly 14 billion years. It's still here all around you. Even as you lie still tonight, it wraps around your room, flows through the air, weaves between your atoms. This is the cosmic microwave background. The gentle, persistent afterglow of the Big Bang. The whisper of when everything began. You may remember, in the early universe, light was trapped, caught in a dense soup of particles. Then at last, the fog cleared. Atoms formed and light, beautiful, scattered, newborn light was released. That release was not a flash, but a flood. Photons poured outward in all directions. And in all the time since, they've kept going. They've stretched with space. They've cooled. Their once blazing energy is softened into faint microwaves. But they've never stopped. This sea of ancient light still exists. We don't see it with our eyes. It's far too faint, far too stretched. But with the right instruments, we can measure it, map it, listen. And when we do, we find something remarkable. Not emptiness, not randomness. We find patterns, slight fluctuations in temperature, tiny variations, in density, like the softest ripples on the surface of a still pond. These ripples are the echoes, the fingerprints of what came before. They tell us that the early universe was not perfectly smooth, and it's in those imperfections that everything we know found its beginning. Because without them, there would be no stars, no galaxies, no planets, no breath, no story, just stillness. The ripples in the cosmic microwave background were tiny, just 1 part in 100,000. But over time, gravity took hold of the denser regions, pulling matter inward, shaping the large-scale structure of the cosmos. These ripples were the seeds, and the light that carries them is still on its way, still painting the sky with its ancient message. In 1989, a satellite called COBE first mapped this light in detail, confirming what theory had long predicted. The results stunned even the scientists. They were looking at the earliest picture of the universe ever seen. Later missions, DMAP and Planck, gave even sharper images. They revealed the age of the universe, the balance of matter and energy, the shape of space itself, all from a whisper. A whisper that began long before Earth existed. It's strange to think that the oldest light in the universe isn't from a star, it's from a time before stars, a time before atoms fully joined, a time when the universe was just beginning to cool, just learning to breathe. And yet that light touches you now. It's part of your environment, just like gravity and heat and motion. Every second, dozens of cosmic, microwave photons pass through your body. They're harmless, silent, gentle, but they're also profound. They are evidence not just of how the universe was, but of how it works. They confirm that the universe began hot and dense. They confirm that space has been expanding ever since. They confirm that even after nearly 14 billion years, some messages are never lost. Think of it like this. You're standing in the middle of a vast ancient cathedral. Long ago, a bell rang just once, and the sound of that bell, though faded and stretched, is still echoing through the stone and air. The cosmic microwave background is that echo. It tells us that the universe has memory. It carries within it the structure, the symmetry, and the smaller symmetries that gave rise to complexity. It links past to present. It connects you here, now in your quiet bed, to the very first moment. It's humbling and also comforting because we don't have to guess how the universe began. We can see it, measure it, feel its ancient glow pressed gently against the edges of everything. It's there in the static between radio stations. It's there in the night sky beyond the stars. It's the most distant light we will ever see. Not because it comes from the farthest object, but because it comes from the earliest time. There is nothing behind it. No deeper path to uncover with light. To go further, we would need a different kind of messenger. Gravitational waves, perhaps ripples in the fabric of spacetime itself. A different kind of echo. But for now, this ancient light is our oldest story, and its existence reassures us that the universe is not unknowable, that its past can be heard if we learn how to listen, and it teaches us something else. Even in expansion, even in fading, something remains. A trace, a tone, a presence. Entropy tells us that energy spreads, that heat flows, that order softens. But even so, the echo stays. Not bright, not loud, but there. So as you drift closer to sleep, let that idea wrap around you. The light of the universe's birth is still here. Soft, persistent, serene, not to wake you, but to remind you that even beginnings echo. And in that echo is a kind of warmth, a reminder that we are not separate from the story, but inside it, shaped by a light that never stopped moving. Next, we return to light's movement. Once more, but this time we think about its speed, its pace, and ask something tender. What if light had traveled faster or slower? What does the universe owe to that particular rhythm? The speed of light. Let's begin with a rhythm. Not a drum beat, not a ticking clock, but something quieter. A pace that holds the fabric of reality together. The speed of light. It is not just fast. It is fundamental, fixed, predictable. The same in every direction from every point in space at every moment in time. Roughly 299,792 km/s, or about $186,000 ms light speed, is not just a number. It is the very pulse of the universe. But why this speed? Why not faster? Why not slower? What would change if a light moved differently? Let's drift into that thought gently. Imagine for a moment a universe where light moves slower, not sluggish, but just reduced. Half the speed, perhaps. What would happen? Suddenly, distances stretch in time. Communication lags, information crawls. The stars still shine, but their messages take longer to arrive. The space between becomes deeper, quieter, more delayed. And more importantly, time itself begins to shift. Because the speed of light isn't just about light, it's about causality, about the order of events, about what can influence what and how, quickly. When light slows, the limits of interaction tighten. Particles can't communicate as fast. Electromagnetic forces which depend on light reach across space more sluggishly. Atoms may hold together differently. Chemistry might falter. Stars might form more slowly or not at all. Now imagine the opposite. A faster light. Information zips. Distances shrink in experience. But this too has consequences. If light moves too fast, structures lose coherence. Energy flows too easily. Stars may burn too rapidly, exhausting their fuel in a flash. The balance between gravity and radiation tips. Life, delicate, patient, may never find its footing. Because so much depends on timing. The balance between forces in your body, in your cells, in your atoms is set by the pace of light. The way molecules vibrate, the way electrons orbit, the way nerves send signals. All are tuned to this rhythm. Your very perception of now is shaped by it. So the speed of light isn't just about how fast something moves. It's a kind of universal conversion factor. It connects space and time. It's the bridge between how far and how long. It defines what it means to move, to change, to become. In physics, it's not just the speed of photons, it's the maximum speed. Anything can carry information. A cosmic limit woven into the structure of reality. And that limit protects the order of events. If information could travel faster than light, effects might come before causes. Time could unravel, paradoxes would bloom. The speed of light is what keeps time flowing forward. So when we ask why this speed, we're really asking why this universe, and perhaps that question has no answer. Perhaps light speed is simply part of the cosmic recipe, one of the deep constants that define what kind of universe we live in. Change it, and you change the entire dish. But we can still marvel at what this rhythm allows. At this particular speed, stars live long enough to form planets. Planets have time to cool, to gather oceans, to support evolution, to grow forests, to wait for questions. And those questions, yours, mine, bounce between neurons at just the right pace for thought, for memory, for dreams. This is a rhythm, not of music, but of meaning. You experience it every time you look at the sky. The starlight you see has traveled across years, decades, millennia. But it always arrives with perfect timing, shaped by the steady drumbeat of light speed. And it's always consistent. If you stood on another world, far from Earth, you would find the same speed, the same constraint, the same gentle limit. Light is the great synchronize. Even Einstein was astonished by this. In his theory of relativity, he didn't begin with gravity or time. He began with light, with the idea that its speed is the same for everyone, no matter how fast they move. That strange truth, counterintuitive and precise, leads to everything else. Time dilation, length contraction, the relativity of simultaneity. All of it flows from that single idea. Light speed never changes. It is the constant in a world of variables. And in that constancy, it becomes something comforting, because no matter how fast we travel, no matter how far a light goes, it always behaves the same. It doesn't age. It doesn't tire. It doesn't bend the rules. It simply is. So when you watch a sunrise or notice the glint of light on a glass of water, you're witnessing not just a flicker, but a truth, a law older than stars, a pace chosen perhaps by the fabric of reality itself. And maybe this is why light feels sacred. It gives vision, it reveals beauty, it nourishes life. But beneath all that, it teaches you about limits, not harsh boundaries, but graceful contours. The speed of light is not a wall, it's a shape. It gives the universe dimension, rhythm, integrity, and it connects. Because in the vast spaces between stars, light is what carries meaning. It is the one thing that can cross that silence. Photons leave distant galaxies and arrive here in telescopes and cameras in your eye, with their message intact. Because of the speed of light, we see the past. Because of its limit, the future arrives gently, not all at once. Even your dreams unfold, in steps, each thought, each breath, each heartbeat. So, as you settle deeper now, remember that light moves through your world in the same way it moves through galaxies. Precisely, patiently, not too fast to lose meaning, not too slow to forget. It's just right, the perfect rhythm for a universe that breathes, that remembers, that creates. And next, we will drift one step further. Because just as light defines space and time, there is another constant, a quiet, deep pulse that shapes everything you are made of. The genetic code, a pattern written in your cells, as ancient and precise as light itself. Tonight we turn inward, not into thought or dream, but deeper still into the small, silent code carried in every cell of your body. A message so soft, so quietly present that you rarely feel it working. And yet it is always working. Even now, as you rest, it hums gently like background music your body never stops hearing. The genetic code, your biological script, your microscopic inheritance, quietly shaping the rhythm of your growth, your healing, your being. It's not written in ink, but in molecules in a long spiral called DNA, coiled tightly inside the nucleus of nearly every cell you carry. Each strand is made of smaller pieces, bases arranged like beads on a string. Adenine, thymine, cytosine, guanine, ATC. 4 letters. That's all it takes to spell a human. But it isn't the letters themselves that matter most. It's the order. Like notes in a song or stars in a constellation, their meaning comes from pattern. And the pattern is precise. Millions upon millions of letters arranged in just the right way to instruct a single cell how to become skin, or bone, or blood, or brain. That's what genes are. Stretches of this sequence that carry instructions, not like commands, but like recipes, gentle guides for building proteins. The workhorses of your body. And those proteins, they do nearly everything. They build structure, carry oxygen, send signals, trigger memory, fight infection, repair damage. You're not just held together by protein, but you're animated by it. And the code for all of it lives quietly inside you. You began with it, from a single cell inherited from 2, 1 from each parent. This code, unspoiled, copied, split, copied again. As you grew, the instructions ran, like a script, directing cells when to divide, when to specialize, when to pause. And though that script is ancient, it is not unchanging. It holds the echoes of generations before you. Not just human generations, but the entire tree of life. DNA is old, billions of years old. The language we speak in our cells is the same one, used by plants, fungi, whales, eagles. Life speaks in one tongue. A leaf and a lion, a mushroom and a person, all shaped by the same 4-letter alphabet. That's part of the wonder. Not only that life has a code, but that all life shares it, like allegory written in variations of the same rhythm. And because it's shared, it can change, very slowly over time. This code shifts not by rewriting itself all at once, but by tiny edits. Changes in a letter here, a swap there. These are mutations, and they're not always bad. In fact, they are the raw material of evolution. Some changes do nothing, some are harmful, but some, rare and quiet, lead to something new, a new trait, a new strength, a different way of being. This is how life grows, by remembering and by changing. The genetic code carries both constancy and creativity. It holds tight to its essential script, but leaves just enough room for innovation. That's how you are both like your ancestors and different. And though it feels invisible, this code shapes everything. From the color of your eyes to the strength of your bones, from how you process sunlight to how you respond to music. Not in a rigid way, but in a scaffold, a foundation on which your life builds its unique form. You're not a prisoner of your code. You're a partner with it. It gives you the structure. You give it direction. Even now in sleep, your body reads from it slowly, rhythmically, repairing tissue, renewing cells, maintaining balance. It's not a fast process, but it is constant, like breath, like tide, and it never forgets. Some cells stop dividing, others divide, often, but the code remains passed down carefully, strand by strand. There are built-in proofreading tools, self-checking systems, redundancy, and repair. And yet, like all things, the code is not perfect. Entropy touches even this. Sometimes mistakes slip through, copies degrade, instructions drift. With age, this becomes more common. The body weathers the changes. But the precision fades a little. Still, the code persists. Even in its flaws, it adapts. It finds new ways to hold you together, new balances to maintain. Even as you sleep now, its instructions continue. Not shouted, but whispered. A molecular lullabies. And in every cell, this message is curled tightly like a secret. If you could stretch the DNA in just one of your cells, it would span about 2 minutes. Now imagine that coiled inside a space invisible to the eye. Multiply that by trillion of cells, and you begin to glimpse the quiet miracle of your body, a library so vast yet so compact, written in a language 4 letters long. And you didn't choose your code. It came to you, carried across time, passed from countless lives before yours, from parents, grandparents, ancestors, reaching back to the first spark of life in variations. But you carry it now, not just as a passenger, but as a storyteller. Because what you do, how you live, what you eat, how you move, how you love shapes, how that code is read. The same gene can act differently in different contexts. Your body listens to the world. The code is stable, but its voice is flexible. It responds to environment, to emotion, to need. Your choices can soften it, activate it, guide it. You're not, you'd just written, that you are writing too. So, as you lie here now, know that your cells are not silent. They are listening. They are working. They are carrying forward a message older than stars and newer than breath. And tomorrow, when you open your eyes again, you will continue that message in your body, your thoughts, your actions. You are the living echo of an ancient rhythm. But that rhythm, like light, does not end with you. It continues forward, passed on, evolving. And next, we'll step outside your body once more. Because just as your cells hold coded memory, so does the Earth, its rocks, its oceans, its shifting plates. They carry the slow-motion record of time. Next, we travel there, to the deep dreaming layers beneath your feet, to plate tectonics, and how the ground beneath you never sleeps. Close your eyes. Let your breath slow. Feel the weight of your body pressing gently into the surface beneath you. The bed, the floor, the ground. You might feel still. You might feel safe. But beneath your resting frame, the earth itself is moving. Not quickly, not suddenly, but always. This is the quiet truth of plate tectonics. The ground beneath you is never truly still. Even as you sleep, continents drift, oceans stretch, mountains are born in slow collisions. The crust of the earth floats like a puzzle pieces on a sea of stone and heat. Let's begin with that image. Earth as a living planet wrapped in layers. The outermost layer, the part you walk on, build on, grow upon, is the crust. But this crust is not solid in one piece. It's fractured, divided into plates, like cracked skin on a warm fruit. Beneath the crust lies the mantle, not liquid, but soft, able to flow over long spans of time. It is slow and hot, moving like thick honey, warmed by the planet's ancient core. And this deep rising heat sets everything into motion. Because heat rises always, even inside a planet. And that rising heat creates convection currents, slow cycles that push and pull the crust above. It's as if the Earth is slowly exhaling, inhaling in deep million-year breaths. The plates above respond to this motion. They drift, grind, separate, collide. You don't feel it. You aren't meant to. The movement is too slow for your senses, just sign. But over time, these small shifts shape the world. Continents are carried across oceans. Mountains rise where plates collide, crumpling upward like a folded rug. Deep trenches form where one plate slips beneath another. Volcanoes bloom at edges where the Earth splits, and earthquakes ripple where pressure builds and breaks. This is how the planet breathes, not with air, but with stone. And it's not random. There's a kind of rhythm to it, a geology of motion, ruled by heat and gravity, by pressure and resistance. Think of it this way. Your body is shaped by invisible systems, circulation, nerves, breath. Earth has systems too, and plate tectonics is one of the oldest, the most essential. Without it, the planet would not be what it is. It wouldn't recycle its crust. Volcanoes wouldn't return minerals to the surface. Mountains wouldn't form to capture clouds and shape rivers. Even life, strange as it sounds, might not have found its footing, because the deep movement of plates helps regulate carbon, balance temperature, sustain ecosystems over time. In a very real way, plate tectonics is part of Earth's immune system. It allows the planet to renew itself. And this renewal has been happening for billions of years. At one time, all the continents were joined together, a single landmass called Pangaea. Slowly, it broke apart. The pieces drifted. New oceans opened. New coasts formed. And now, the continents continue their journey, silently, floating on molten rock, redrawing the map of the world, 1 inch at a time. Your home, your country, your memories, all resting on a plate that moves. And this motion, though slow, connects you to the very core of the Earth, to a place you'll never visit. But that shapes every day of your life, because the plates also carry history. When they move, they lift ancient rocks to the surface. They bury seabeds under mountains. They stir fossils into stone. They tell the story of what came before. Geologists read these stories like pages in a deep rocky book. Each layer a memory of climate, of catastrophe, of change. Even mass extinctions are written in the crust, marked by ash and pressure and pores. You could spend a lifetime reading that book. And the more we learn, the more we see how alive the Earth truly is. Not just biologically, but geologically. It shifts, it pulses, it balances itself. And like your body, it sometimes breaks with earthquakes, eruptions, storms. But even these are part of its larger rhythm. Not punishment, not warning, just process. The Earth is not angry, it is active. And like all active systems, it leaves space for beauty. The Himalayas rising from a plate collision. Iceland born from a volcanic seam. The Andes, the Alps, the Rockies, all sculpted by the slow dance of plates. And beneath the ocean, where we rarely look, ridges stretch across the seafloor. Underwater mountain chains that wind around the planet like stitches on a globe. They are growing even now. New crust forms, there as magma rises and cools. The Earth is building itself cell by cell. And even the ground beneath your pillow was once molten, once drifting, once buried beneath something else. It may be again. And so as you rest now, you are part of a larger stillness, one that moves beneath the threshold of your awareness, a geological heartbeat. It's strange to think that the solid Earth, the foundation we build everything on, is one of the most fluid systems of all. But perhaps that's the secret of strength. Not in resisting change, but in allowing it. The ground shifts, the plates slide, the mountains rise and fall, and yet life holds on. Life adapts. Your ancestors felt earthquakes, climbed hills newly born, saw the ocean creep closer or farther, and now you inherit their wonder, shaped by a planet that never sleeps, a planet that dreams in stone. Let that comfort you. You're not standing on a frozen world. You're lying on a planet in motion, slow, graceful, powerful, and just as your breath follows a rhythm, so does the crust beneath you, rising, falling, rebuilding. And next, we go deeper still. Not beneath your feet, but beneath time, because Earth's movement doesn't just shape the land, it shapes memory in the layers it keeps, the warmth it releases, the energy it stores. Next, we listen for that energy. We drift toward one of the planet's oldest voices, the supervolcanoes, and the quiet power that sleeps beneath the surface. You lie above silence, above green fields, still waters, snowy woods. But beneath them, miles down, Earth keeps a secret, a slow, swelling heat. A pressure that builds not in hours, but in centuries. Beneath your feet, the planet dreams its deepest, dreams in chambers of molten stone. These are the supervolcanoes, not mountains that erupt often like the quick-breathing volcanoes of island chains, but vast reservoirs of magma hidden under plains, forests, and lakes. So quiet, so slow that we forget they're there at all. But they are. And tonight we drift, downward into their heat, into their patience, into the story of how Earth breathes through fire. Let's begin with Yellowstone. Today it's a park full of life, bison, bubbling springs. Beneath it, a sleeping giant. A magma chamber so vast that if it stirred it could darken skies and cool climates. But it doesn't stir quickly. It dreams in deep time. Supervolcanoes are not defined by shape. Most aren't even mountains. They're defined by scale. When they erupt, and they rarely do, they change the world. Ash falls across continents. Temperatures drop. Sunlight dims. They don't just affect the land. They affect climate, life, evolution. But these eruptions are rare, separated by hundreds of thousands of years. And in between, the volcano breathes, slowly, swelling, settling, waiting, like Earth pressing a warm cloth to its deepest places. The pressure that feeds a supervolcano comes from below, from rising magma, melted rock created by heat and pressure in the mantle. Over time, magma pools in vast underground chambers. If it finds no release, it waits. If it finds weakness, it rises. But don't be afraid. These processes are slow, glacial, measured in tens of thousands of years. We live in the pause between pulses, the deep inhale before the planet exhales. Most of the time, supervolcanoes are invisible. We walk above them. We swim in lakes that rest on ancient calderas, the wide, collapsed bowls left behind by long-ago eruptions. We camp in forests that grow from volcanic soil, rich with minerals returned from Earth's interior. You've likely walked on the back of a supervolcano without knowing it. Lake Tobarin, Indonesia, Long Valley in California, Tau in New Zealand. These are not ticking clocks. They are more like pressure gauges responding slowly to heat from below, like tea kettles on the lowest simmer. And what's astonishing is how alive these sleeping giants make the planet. Their heat powers geysers, hot springs, underground aquifers. They send up minerals that feed bacteria, then plants, then whole ecosystems. They build landscapes and eventually reshape them again. Even their ashes, when they fall, become part of life's renewal. Because volcanic ash, though suffocating at her first, enriches soil. It carries nutrients. It helps forests regrow. After darkness comes green. Supervolcanoes are not destroyers. They are part of Earth's cycle, part of how heat escapes from deep within, part of how pressure is released, structure rebuilt, memory reformed. And in their presence, we're reminded of scale, of how much longer the planet's time is than ours. We measure in years, in decades, in lifetimes. But supervolcanoes measure in epochs. Their last breath might have been before humans learned to speak. Their next might not come until long after our cities have faded. And yet, they are part of our story. Some scientists believe a supervolcano eruption helped shape the path of human evolution by cooling the climate, by shrinking forests, by forcing small groups of humans to adapt, to migrate, to grow resilient. In this way, even silence becomes influence. Even sleep becomes change. And this is what the supervolcano teaches. That power can be slow. That presence does not need noise. That even in stillness, the earth is moving, storing, shifting, preparing. You live on a breathing planet. Its breath is not shallow. It is vast. The heat beneath your feet has been there since the beginning, left over from the planet's formation, from impacts and compression, from radioactive decay still happening deep within the core. And sometimes that heat surfaces, not to destroy, but to remind, to write a new layer into Earth's crust, to whisper in ash and steam that nothing truly stays the same, even the ground. And yet tonight, that ground holds you gently. The supervolcano beneath Yellowstone may not erupt for another 100,000 years or ever again. Others too remain asleep, breathing warmth, but not fire. They are not threats. They are memory reminders that Earth is alive beneath your still bed. That silence does not mean stillness. That the most powerful changes begin slowly with heat moving upward unnoticed. And that sleep, even in mountains, is full of potential. So lie still now. Feel the warmth of your blanket, the softness of your breath. Imagine far below a slow tide of magma resting against stone. Ancient, unhurried, wise. It waits not in menace, but in patience, just like the plates that drift, just like the atoms in your cells, just like the stars that shine from their own slow burn. And now, as the earth sleeps beneath you, we turn our gaze one final time. We leave the crust, the code, the echoes. We return to where we began, to motion and to time. Because in all these chapters, the drifting of galaxies, the cooling of space, the flickering of light, the shifting of ground, we have been tracing unquiet truth that entropy is not destruction. It is change. It is time unfolding. It is the universe becoming. Time isn't ticking. It's stretching, flowing, unfolding like a soft fabric laid across everything, stars, stones, cells, and breath. You feel it pass moment by moment, but the universe feels it change. What we call time is deeply connected to something subtler. Entropy, the measure of how things spread, mix, and soften. Not disorder for its own sake, but a natural easing of energy from tight bundles into open space, of patterns into possibilities. It's why heat flows from hot to cold, why ice melts, why stars shine and fade, why your memories have a direction, why you remember yesterday, but not tomorrow. Entropy gives time its arrow. Without it, time would be shapeless, motionless. There would be no before, no after, only a still moment, endlessly frozen. But we do not live in that kind of world. We live in a world where everything changes slowly, gently, unceasingly. A world where molecules drift, where light stretches, where mountains rise, fall, and rise again. Where galaxies spin like snowflakes in a deepening sky. Entropy does not rush. It moves like a tide, sometimes crashing in brief moments, an explosion, a heartbeat, a laugh, sometimes barely moving, the cool of a rock, the pause between dreams, but always forward. Entropy tells us that the universe began in a low entropy state, tightly wound, full of potential. And from that beginning, everything has unfolded, each step allowing more possibilities, more combinations, more diversity, more motion, and more softness. Imagine a cup of coffee just stirred. At first, the cream forms swirls, ribbons of contrast. Over time, those patterns fade. The cream blends. The warmth evens out. The system doesn't stop. It just settles. This is entropy, the art of settling, not as an ending, but as a gentle release from tension. The universe is doing the same. It's not rushing toward death. It's relaxing into balance. And we, for a short time, are part of that process. Your body is an island of low entropy, full of structure, energy, pattern, and every moment it trades energy with the world. You radiate heat, you burn fuel, you think, you move. Each of those actions gently increases entropy. And in doing so, you live. Your life is not a fight against entropy. It is a dance with it. You create temporary order. You write, build, love, sing, all while your body quietly glows with the warmth of its own motion. You are a candle lit for a time, shining against a backdrop of cooling stars. And when you sleep, entropy doesn't stop. Your body repairs. Your brain reorders memories, softens noise, reshapes experience. Sleep itself is a kind of balance, a return to internal calm, a daily settling. And now, as this journey comes to its final chapter, you can feel that stillness arriving, like entropy reaching equilibrium, like breath slowing after a long walk. The universe is not a clock that winds down. It is a story that deepens. Entropy doesn't erase the past. It carries it forward, blended, stretched, softened into the present. And you are still in it, still unfolding, still connected to the first fire, the drifting light, the dancing atoms, still part of time's quiet motion. So let yourself rest now. Let your thoughts unspool like starlight across a widening sky. The science will wait. The stars will keep spinning. The earth will keep breathing. And you, small flame, soft mind, curious heart, you've earned this peace. If you've enjoyed this quiet journey through the science of sleep and the sleep of science, I'd be grateful if you'd give this video a gentle like. And if you'd like more thoughtful, soothing explorations like this one, consider subscribing. Your support helps this calm little corner of the internet grow, and it lets me keep making peaceful science for curious minds like yours. Wherever you are and whenever you listen, thank you for being here. Now rest. You are made of stardust, and the stars are tired too.